So welcome to the FHIR seminar of HL7 Finland. We're arranging, actually this must be third FHIR related event this year in Finland, arranged by HL7 Finland Association. And I'm happy that we are getting more and more people involved in both in the seminar, and we are also having a training. Many of you have also registered for beginning on afternoon. So I'm glad you have made it here. So my name is Juha Mykkänen. I'm chair of HL7 Finland Association. I work at the National Institute for Health and Welfare, THL. And so welcome everyone. We are having a nice program today for the morning seminar. So we are having introduction and a tutorial types of things for FHIR standard. I'm sure lots of you already know quite a bit about it, but not everyone. So we are aiming to have a balanced set of introductory and what it means to use FHIR, but also what it going down towards how to design, how to use, what are the main important things when you're designing FHIR-based solutions and interfaces. So we are having guest speakers, especially from FHIR, the Netherlands. So Ewout Kramer and Mirjam Baltus. Mirjam will be mainly speaking for the training part in the afternoon, and Ewout will be mainly speaking for the seminar part today. Today we also have a roundtable of Finnish FHIR users, where we can hear some of the experience and some of the expectations of the Finnish users who have been using FHIR. Some or many of you may already know that we had a quite well-attended FHIR demo in Terveydenhuollon ATK-päivät in May. And we got pretty good experience from that. There are several other people who are not part of the roundtable who were also attending, so we are hoping you can also say something about your experience of using FHIR. And in the end of the morning session, we are going to have some more discussion about the next steps of FHIR use in Finland and what we should be doing together in Finland. How should we participate in the international development of FHIR and the next versions, and what would be good things and concrete things to work on. So we're having a program like this. We're having a coffee break at 10:20, so the coffee will be served right outside this room. Everyone for the morning seminar is also welcome to the lunch after the seminar, and the lunch is served in a restaurant on the other side of the inner yard. So if you are hungry after the seminar, feel free to join the lunch as well. There is a Wi-Fi connection that was displayed here. It's easy if you go to Scandic Easy network, and you can just sign in. I hope it works. Yeah, it works with your name and phone number, so you can use those things. Okay, but this is our program. Today we are going to talk about interoperability, and well, that's a very fashionable word at the moment. Everyone is talking about it, and everyone is looking at it. But how we are looking at it? What kind of interoperability are we talking about? Are we talking about semantic? You can actually process meaningful information. Are we talking about how people interoperate, how you can understand and use in your daily work the information that has been transferred? FHIR, the F word, there is the fast. So how to make it fast? Interoperability projects have a little bit of bad reputation of being slow, cumbersome, complex. Well, the complexity must go somewhere, but are there some things that can be made faster? So that's some of the things that we're going to talk about. And we are talking about standards. Standards in a sense that they are shared, they are approved, there is a level of trust in the process that standards are being developed, and what's the use there. So how does the new FHIR standard help us there? So that's one of the important aspects of interoperability. But I think there is even more important aspect. For what and for whom are we building the interoperability things? There are differences. If we are doing that for hospitals, today we are going to hear about how FHIR standard is used for personal health things, personal health records, the infrastructure in Finland, which deals with personal health, and consumer, patient, citizen side of things. Or are we using the new standards to support the big changes we are facing, social and healthcare reform or some other things? So where do we use it? What are the use cases? What are the shared use cases we should be working on together? These are also important things, and perhaps even more important than the technical side of things. So how do we use the new standards for these different kinds of purposes? I hope we can get to that discussion as well. But I think the program today will enable us to discuss some of this and learn about the FHIR and how it can help us with these kinds of challenges. So this is the opening. I think we can move forward with the program. If there are immediate questions about the arrangements or things like that.
Sorry, one question.
Yes.
Where can I find all document presentation from this meeting?
The presentations of this meeting will be available in HL7 Finland website. They are not there yet, but we will upload them.
But this documentations will be just sent to someone. How can I get the link?
The link will be sent to all the registered participants.
Okay.
Okay. Thank you. Okay. So we are moving forward, and we are the next part of the program will be led by Ewout.
All right.
So please.
I'm going to kick you out. Good morning.
Good morning.
So just a little test. I think the microphone is working for those people there on the camera. Maybe a little bit too good. Yeah, better. Does the sound okay?
Yes.
Great. Well, it's been a long time that it didn't work out of the box. Yeah. So far for So far for standardization.
Yes, thank you. 100 years.
Plug this into USB. That works. Okay, good morning everyone. My name is Ewart Kramer. I've been coming here yesterday from Amsterdam, but more importantly, I've been involved for a few years in developing the FHIR standard together with a few other crazy people. I'm going to tell you a little bit about also today about why we did that and what we did. So this morning I will focus more or less on the high-level aspects of the specification. Just an overview to get everyone at the same level. And then Miriam will go more in depth, especially tomorrow with the developer training. That being said, me myself, I'm a software developer as well. And that background is important for understanding where FHIR came from. We wrote FHIR to be friendly to software developers. Now, I will start out with a question for you. Who of you here is a software developer who develops software for healthcare? Ah. So who is definitely a non-techie here in this room? Ah, one. Right. Okay. This is not going to be technical, so don't worry. I'm just giving, I'm giving you some background on the FHIR specification. I'm talk a little bit, of course, what's in the box for the FHIR specification. Who here has already taken a look at FHIR or has worked with FHIR? Ah, that's quite a lot. Well, so then maybe for some of you, what I'm going to tell you is nothing new, but it might still be interesting to have some of the background on why we did it and future plans and so on. Okay, let's take a look. Of course, this doesn't work either. Oh, yes, it does. Fast. All right, FHIR. So before I get off, I will spell out FHIR for you because it's a bit of a weird word. It sounds like fire, but we spell it differently, and that's of course because we wanted to make sure that if you Google FHIR, you would find our specification. Now, and nowadays, if you want to reserve domains, you have to first choose a name, see if that's available, and then that's your final name. So the committee who thought of FHIR thought, let's pick a word that's easily findable. So FHIR, we first picked the letters and then we picked the meaning. So F, fast, yes. You already mentioned the word fast on his slides. We wanted health interoperability to become way more easier. You don't have to study for 10 years to work with healthcare technologies. You just should be able to use it out of the box. So fast. Healthcare interoperability, well that's easy, that's what we're talking about of course here. And finally the R is the word resources. It's more or less a technical term. And it comes from the R, the same R as in REST, resources. Entities somewhere in the web that you want to exchange. So there's a bit of everything here. Fast healthcare, interoperability, resources, FHIR. Resources are also the most important aspect of the FHIR specification. The whole specification is built around these resources, so for sure I will get back to that. To be sure, the full name of the FHIR specification is HL7 FHIR. So wherever you mention it, I've done it now, see, follow my good lead. You always once say HL7 FHIR, with all the trademarks in place, of course. I will tell you a little bit about HL7. I said when we just started with FHIR, many people that sat here were familiar with HL7, but more and more, I meet people here at these meetings that are completely new to healthcare, and at the end they come to me and they say, "You've been talking about HL7, but what is HL7?" So allow me a little bit of time to also start at the very beginning. HL7, what is HL7 actually? HL7 is a standards development organization. That means that's a bunch of fools who think it's interesting to sit together and standardize data models and technologies around healthcare. I like going to these meetings. They're 3 times a year. We come together in the US and we sit down and we discuss healthcare interoperability. If you would take a look at their room with all those characteristic fools, you'd say, what's fun about it? But yes, it's somehow it's fun. So HL7 already maybe for 30 years is thinking about how do we let computers interact in a standardized way. So HL7 has a history. HL7 is also an accredited standards organization, so it means that they follow a kind of process with feedback loops and everything to get to a kind of a final version of a standard. And that's what HL7 does. They make projects with funny names, like Sea Cow was one. And their main project actually has no name. Their main project was called HL7, the name of the organization, version 2. We don't know version 2 of what, but it was called version 2, just version 2. There's supposed to be a version 1 somewhere in the last, maybe in the 80s, but no one has ever seen it. So the first thing that people think about when they hear HL7 is HL7 version 2. And this is about, I don't know, about 20 years old. It originated from lab communications, and it was a really nice, simple standard. If you read the documentation, as a software engineer, you more or less know what you want to do. You just read through it and think, oh, I know how this works. Download a few libraries, and you get cracking. Easy as that. So I like to compare HL7 version 2 with Duplo Lego. Big blocks. If you wanted to build a house, there's actually just one or maybe two ways to do it. If you want to build something that looks a little bit different than that, well, you would have to start cutting the blocks because there's not so much fine-grained things to do. If you want to adapt the standard to what you need for your organization or your software, you don't have that much flexibility. But the good thing is, you look at where you want to go, you look at your basic building blocks, and you more or less know how to build it. That's the good thing about HL7 version 2. It was also still, in some ways, so flexible that some people say, if you've seen one version 2 interaction, you've only seen one. Multiple systems still had to be adopted and changed to be able to use version 2. So it was not really out of the box. So what happened after some time? The HL7 organization came together and say, well, this time around we really know how to do it right. We're going to make the successor to HL7 version 2, which was of course called HL7 version 3. Well, for those, this is what I say to all my colleagues who are not into technology, but especially to our salespeople. For those who don't know, version 3 is a successor to version 2, but it's not an upgrade from version 2. If you build a version 2 system, you can't just change a few things and then say, update, update, I'm at version 3. Those are completely different standards. That's important to realize once you start working with HL7 version 2. And FHIR is exactly the same. FHIR is not, we didn't call it version 4, and FHIR is not an upgrade to HL7 version 3. It's a totally different standard. If I compare version 2 to Duplo Lego, then I think version 3 looks like this. This time we really know how to do it. We make these really, really small blocks, so you can create endless amounts of standards yourself, because that's what version 3 is. It's a standard set of building blocks to create standardized medical documents, standardized messages to exchange data. I don't know about you, but I played with Lego when I was young, and I'm not very creative. So if I wanted to build stuff like this, it's possible if you have blocks like this, but I didn't know how to do it. I would always need, that little booklet that comes in the box, in the Lego box, and I would just faithfully take all this stuff and build that. And I think, without going into any depth in version 3, that was also the weakness of version 3. If you wanted to work with the version 3 standard as a software vendor, you needed someone to write this book for you. Because there is so much freedom in the basic building blocks of version 3 that the chance of two organizations who wanted both to exchange, say, prescription data for GPs, the chance that they would start with these blocks and end up with the same solution so you could interoperate, that chance was almost next to zero. So to make that work, some international or national standard development organization would have to write this little book and write down exactly how to do it. But that meant that as a software vendor, you would have to wait for your national standard development organization to write this book for you before you could do anything useful with prescriptions, for example. And we wanted to change that. We wanted people in FHIR to be able to say, I just want to get cracking. Give me some, some starter materials, some things to get started, and I want to use the standard even without the standard development organization present. That's one of the things we wanted to achieve with FHIR. I showed you the Lego there, the very small blocks. And I'm just going to make a small deviation about standards and how they go about with total flexibility and very specific things. If you have total flexibility in a standard, the good thing about it is that you can still do anything with it. Just like an empty Word document or an empty screen in your code editor or a piece of A4. It's a very flexible standard. An A4 piece of paper is a flexible standard. It's a standard, but you can still do anything with it. It's very flexible. But the chance that you will do, if you want to exchange with another system, and you have such flexible standards, the chance that you do it exactly the same way are practically zero. On the other hand of this, so this is like, say, the Lego, these pieces, as I said, you can combine them in so many ways. The chance with just such generic standards that two vendors will do exactly the same thing is minimal. On the other side of the spectrum, I have that completely described piece of Lego here. And of course, if two people build standards according to these specifications, they will build exactly the same thing. If we're talking about prescriptions, we're talking about the same kind of prescriptions. So, on one hand of this whole schema, you have a very generic standards which is extremely reusable. You can use them for everything, and that's nice. But the chance that if two vendors use it, can communicate, is very, very low. On the other hand of this whole scale, you have single-purpose standards that have very specific documentation. If you give it to two developers, they will build the same solution, but you can only use it for one thing. And I think in between those two extremes, we can find something like half-baked products. Things that are not as flexible as this, but at least try to tell you, well, if you want to do prescriptions, or you want to exchange, or you want to build a provider registry, this is what we think a provider looks like. And that's where FHIR is, more or less. If you have this, I have here for you the whole scala of a few famous standards. And totally on the left-hand side, you see HL7 version 3 reference information and OpenEHR reference model. These are actually very flexible. They can be made into anything. You could even use HL7 version 3 maybe to encode lots of financial information or veterinarian clinics or whatever. So still a lot can be done on the left-hand side. On the very specific side of the scale are the IHE standards that are so specific but they are made for a single use case. So if you build a new standard like FHIR, where are you going to position yourself? Well, if you compare us to version 3, we try to move that way. FHIR is a box full of quite specific models. Not completely specific for a single use case, but somewhere halfway. And FHIR added on top of that a thing called FHIR profiles, which I'm going to talk about after the break, that allows you to turn these semi-generic FHIR models into a specific use case, specific solution. So this is the way FHIR tried to solve that interoperability problem. On the one hand, give you flexible models, on the other hand, give you a tool to say, yeah, but if we use it in the context of Finnish provider directory or Finnish medications, this is how you need to do it, and that's FHIR profiles. Flexibility versus usability. All right. So once we solved that problem, as I said, I myself was a software developer, and version 3, which showed you a very flexible set of Lego blocks, was really made, I think, for the modelers. It was a modeler's dream. It has all the tools to make consistent data standards, just what modelers really want, what standard development organizations want. But as a software developer, which I am, very flexible standards mean flexible software, mean expensive software, means standards that are hard to implement. And we wanted to focus, when we started to design FHIR, we wanted to focus back on the implementers. We wanted thousands of examples in the specification, so you can just take a look at a piece of XML and say, oh, that's how it works. We wanted servers to be available in the cloud from the very first moment, so that if you wanted to try out FHIR, there would be at least 1 or 2 servers in the cloud that you could just talk to with your software. We wanted ready-made assemblies in .NET or Java or Delphi, so you could just download that and start working. That's what we wanted. Focus on the implementers, because if implementers like your standard, there's a good chance that your standard will get used. Version 3 had the problem that most vendors would only use it when they got paid by the government to use it. We as a government have made up this standard. We have a sponsored project for you to use it. Please build it into your software. And then vendors would say, okay, in that case I do it. But what we wanted is a standard where vendors would say, well, actually, instead of inventing something myself, look at all these tools. Look at all these libraries. It's already there. You could even say, I don't care, it's a standard. It's a very useful framework to use for health IT, so I'm going to work on it. So that's what we wanted. We also wanted simple things to be simple. Now, some people say FHIR solves everything. No. Luckily, our field, health IT, is complex. That's why I am in health IT. It has some really nice puzzles to do, and FHIR can't make these easier. But the least you can do with your standard, your interoperability standard, is make sure that the easy things are easy, that people have an easy path into the standard. You don't have to read the full 2,000 HTML pages that are in the standard. You can start, and Miriam will probably do that in the coming time, and in maybe an hour be able to exchange patient data. That was not possible with our previous standard. FHIR made it possible to do that because the easy things are easy. But the hard things are still hard, by the way. Leverage existing technologies. Well, everyone likes to invent their own stuff, right? And this is what HL7 as an organization did. Any existing technology was maybe not good enough. So we always can find reasons not to use an existing technology and invent something yourself. Inventing something yourself is fun. I like doing that. But we wanted to try as much as possible to say, no, we're not going to do that. We're going to make sure that what we do works with existing technologies. And let's say people who come from a different background, maybe from finance or app developers who write apps for advertisement agencies. I don't know. They would have to come to the FHIR standard, read it, and say, yeah, so what's so special about this? Just a normal API library like Twitter or Facebook. That's what we wanted to achieve. We wanted people to not be surprised when they looked at the specification. And finally, make it freely available. The previous standards from HL7, you had to be member behind a paid firewall to download it. Causes all kinds of problems. If you then develop software that has that standard built into it, can you still talk freely about it? And what I hate is people telling me you have to use that standard, like with ISO. You go to the ISO website and you have to pay 250 Swiss francs to use the ISO standard. Well, I will Google the illegal version. Right? So we thought it was very important that everything around FHIR is freely available. This is even true for the slides, by the way. My slides, if you get them, they're Creative Commons. You can do whatever you like. If you want to use them within your company, feel free to do. And finally, invoke the community. The standards community is a crazy but small community, and they used to have it all for themselves. So once every year and a half, they would send each other's Excel sheets with changes they wanted to make to the standards, discuss it all by themselves. What we wanted was anyone using the FHIR standard to be able to send in requests for changes. Just a link. Here is our bug tracker. Send in whatever you want. That was hard. The whole organization had to change a little bit to make that happen. If you're used to just, receiving a few comments here and there, and now suddenly anyone can send in requests for change, that was a shock for HL7 as a standards development organization. Standards development is slow, and people want it fast. There's always a little bit of tension there. But feedback from the community, in the end, when I started with FHIR, I had just these 4 ones. Only later we realized how important it was, all the feedback we got back into the specification, and that changed the specification. So, main thing here, focus on the implementers. Simply said, if you look at the FHIR specification and you can't make it work in the weekend, it's too hard. On Friday you go home, and on Monday you say to your development team, well, I read through it and I think we can use this. It's okay. I didn't read everything, but it should be okay. That's what we wanted to achieve. Another thing, when we were thinking about FHIR, the moment we were thinking about FHIR, this must have been about 2012, was of course the rise, as I say, the rise of the API. First, HL7 had no answer about the more modern developments that came into play, like all the mobile technologies. We are so much used to our mobile being, and I think it's going to be actually, I think it's going to be even more so the case, that your mobile phone is actually your central point of information. You don't go out to websites to fetch information. You don't. I was saying to everyone, just look at this example. This is a map of the Netherlands, and here on this phone I have a travel app. It's already possible that if I travel to someone, I just type his name. The name will come automatically from my Exchange server of my company, from the LinkedIn. Everyone who puts his contact information on LinkedIn, I automatically have that on my phone. I select it in the travel planner. The travel planner goes out to the website for me of 9292, which is our national public transport organization. This in turn, of course, will, even if I travel across the Netherlands with all these kinds of different public transport companies, their system will have connected and know all the times of the buses, all the delays, and plan my journey. It will plot it on Google Maps, and finally I can look at TripIt, whether one of my colleagues is also on the same trip. So this whole story, all these arrows are towards your mobile phone. Your mobile phone needs to be able to get out into processes of other organizations and combine all the data into one, rather than you going to this website to find an address, then go to that website, then look at Google. We're already used to the fact that the mobile device is becoming the big aggregator and coordinator of data. Everything will be here. Really, your mobile phone isn't so mobile, it's always with you. Our previous standards had no answer to these questions. We couldn't make an API with that, not out of the box. So, for us important became to support the API economy. Companies opening up their internal processes, and if I say company in this case, might be GPs, hospitals, opening up their internal data structures to third parties, so you could write creative and new apps with data that's inside a hospital. You can't expect a big EHR vendor or a hospital to go and write all kinds of innovative applications for maybe small patient groups. I do expect innovative companies to do that, to write apps. And we want to be able, for FHIR, to cover that. So I call it the rise of the API. HL7 wanted to provide technology for you, maybe as a server writer, to write an API in front of your server so others could take advantage of the data inside your system. And on the other hand, we wanted to make it really, really easy for app developers, maybe coming from different industries, to call those APIs and get to the data. Those were our targets. And we're not the only ones who did that. When I made this presentation for the first time in 2012, I went to this website, I forget the name of it, Programmable Web. And they kept a web services directory, so a number of these kind of public APIs available on the web. I had 5,716 by that time. And when I did this presentation in 2016, I had almost 15,000 companies publishing an API. So there's no doubt for me that this is one of the important things that we're going to see developers do, and that's reach out and combine APIs from others, 15,000 APIs. So HL7 and FHIR, with FHIR HL7 tried to jump on that API bandwagon, allow companies like Cerner or Epic or the big EHR vendors, also your national EHR vendors, to develop these APIs. Of course, HL7 is a standards development organization, so we're a little bit, we try, like Twitter and Facebook, to build these APIs so you can talk to the systems, but HL7 has no functionality to offer, right? We just offer a standard. Others have to put this API on their server, so that's a little bit different. So you could say FHIR is a set of flexible, standardized data models, plus a very useful way to create RESTful healthcare APIs. So third-party developers can then seamlessly connect to a FHIR API on a server. So the whole word standard is not really here. Standardized models, maybe. So we have these little data models in the FHIR standard. But I think for many developers, FHIR will be just a very useful way to create APIs on top of their systems. And the fact that it's standardized, well, it's a nice takeaway. If I can coordinate with a few of my competitors or people that I want to exchange, it's easy that I didn't make it up myself and just send them a link to the FHIR spec and says, we're actually using this. But otherwise, it's very useful that there are so many tools available, so many libraries. You could also say, well, whatever, that's a standard. It's just a very useful API generation framework. So before I get into FHIR technology, Juha here asked me to introduce you to another subject that is not really connected to FHIR, but it is connected to standardization and interoperability. I already said the FHIR API is kind of making it easy to interoperate, but not necessarily standard. Why would we standardize? If 3 companies use FHIR to interoperate, have they standardized anything? Is it important to standardize data across the whole of Finland? It's these kind of questions that are important at this point, because people are looking at FHIR and using FHIR as well to take a new look at their national strategy for standardization. And so always the questions come up, whether I'm in the Netherlands or Germany or here in Finland or Sweden, or yesterday actually we had a Nordic meeting, the question that comes up is, do we need to standardize across countries? Is that really necessary? And I just want to diverge a little bit and talk about that. So first, if you wanted to standardize everything, why would that be so hard? Why is universal standardization so hard? There are a few reasons why why this would be the case. The first is the easiest one. Standardization and the number of standards there are most of the time also based on egos. Not always, because these are big, ego guys. This is a typical situation. There are 14 competing standards, and you sit together and say, that is weird. We have 14 standards. Shouldn't we pick one? And by the time you finish your discussion, we all know what happens. We have 15. I reflected back on this yesterday when we were with the Swedes, the Finnish, the Danes, and the Nordics, and the Norwegians talking about, should we standardize? And you could say, well, let's take the strategy of one of these countries and choose that as our strategy, choose that as our standard, and we know this will never happen. If you sit together with the 4 of you, you will develop a new plan, a 5th plan. And then if you decide that the Netherlands or Germany can join, they will say, yeah, it's nice, but we need to, it's slightly different, and you have a 6th standard. That's just how it goes. So picking someone else's standard is hard enough. And you could say when we started to develop FHIR, that's really also what we did. We said to version 3, yeah, it's nice, but we know how to do this better, so we made yet another standard. It's on multiple levels. It's not always about egos, it's also about idealism. You think that by now, with this group of people in the room, we know really how to make a new standard or a new set of data around personal health care. So let's get this done. And what you always end up is with a new set of data for PHR that is just incompatible with what's already there. So that's one of the reasons why there's an incredible number of standards. And it's very important when we're thinking about a new national or maybe, who knows, European strategy for exchanging data, that we take a good look at, do we want to limit it to one? Or is it actually just perfect if every single country chooses its own one? There's reasons maybe why that happens. The second reason why there's always problems with standardization is cost. Now this is the big story between maybe you as a vendor, maybe I as a vendor, and standards developing organizations. If you're a developer, here, see, clearly this is a developer, t-shirt, logos. If you're a developer and you need to build a new solution in, let's say, 8 weeks or 2 months, you want to spend your time on functionality. Maybe not so much on standardization. Standardization isn't your hobby. You just want to make sure that you can connect to other systems. So you say, well, here's my use case. You want me to use FHIR? Fine. Let me just build that software. So I want to communicate first and then standardize. Well, I don't know if my competitor is doing the same thing. I don't know if on a national level there's all kinds of plans from a national standard development organization. I just need to get this done. So I'm talking to my other software developer that I need to exchange data with, and then how are you doing it this way? Okay, that's how we build it. Fine. We don't look at the rest. It needs to be ready next month. I don't care. Communicate first, harmonize later. Is that a bad thing? I don't know. On the other side of the spectrum, you see the people at the table. These are the standardization organizations, of course. Standardize first, communicate later. We need to be sure, that's what they always will say, before a single letter of software gets written, we need to be sure that everything is standardized. So let's sit back, let's wait a little bit. Let's take a look at the whole spectrum of data models and let's standardize those first. This needs to be done because this takes time, right? You need feedback from IT persons, you need feedback from vendors, you need feedback from doctors. This is a slow process. I think you would agree that if we all wait on this, it takes ages before finally you have the standards you need to make your software. But if we do this, there will hardly be any kind of standardization at all. People will just go off and start doing it. And that is what happens. So which of those two parties are right? The answer isn't so simple. And that's what I say to many standards development organizations. I think it's no problem if vendors first start maybe for very specialized use cases, let's say GP medications. If people working on general practitioner software and they say, well, let's just first make sure that these things can communicate within our region. And then based on that experience, maybe we'll scale up to a national standard. Is that such a bad idea? I don't think it will end in chaos. And I will show you why. Anyway, I also say always to these people, if you think you have all the time in the world before you can put out your standards, don't forget that he who ships code wins. In the end, the way standards are being used and built into software, in the end will become fixed. So third, and this is actually a conclusion of the first two, the reason that so many standards exist and that people not always want to wait for a centralized standard is that there are very good reasons why you would just take FHIR out of the box. That's the international flavor. As I said, it was somewhere in the middle of that whole scale. So it still has enough flexibilities so that maybe if a cancer center, a software for cancer centers uses prescription and GP systems using prescriptions, if they don't communicate, they probably use FHIR in different ways and they won't be completely pluggable. It's important to understand. If you both give them the FHIR specification, they'll be able to exchange basic patient data without problems. But prescriptions, though they are in the FHIR box, they are still very flexible. So the chance that these could just plug and play interoperability, that's not guaranteed. Is that such a big problem? Not really. If this is used to communicate within GPs, and those are used for cancer centers to communicate, it will just work fine. Because there is no real reason these two should communicate. As long as communities can use their own standards, if you're with 3 people and you want to use FHIR to exchange stuff with 3 people, maybe that's fine. Maybe at some point later, of course, people say, well, now we want to build a regional portal where a patient can see his GP medications, but also medications coming out of these cancer centers. And then there's a real business reason to say, okay, then based on the experience here, let's get back to the table and see what we have to change to make stuff work across these organizations. But then there is a use case, and most of the time then there's money, and there's time, and there's a project, a budget to make this work. There's a real use case with which you can put these vendors together on the table and say, make this work. Of course, this scales up to a national level as well. I call this bottom-up standardization. And I think with our previous standards, most of the time what we wanted to do is do everything top-down. As I said, wait for a standards development organization to write that little Lego book for you so you could then finally build your applications. But it means you have to stick to the time schedules of your national institutions. With FHIR we wanted to enable people to just start. At the same time, of course, if there are national standards for patient data, provider data, why wouldn't you use it? In the Netherlands, for example, we have standardized the way we encode organizations and patients already in version 2 and version 3. So we immediately copied that approach to FHIR. There's no point, these things can be done early and top down, but there's all kinds of things where the innovation happens that you need to say, as a standard development organization, well, let these people do their work first, and we'll standardize later. That's a lot of boom, boom, boom. Okay. Any questions about that? Yes.
How do you fire in like just context with standard HL7 version 2.0 messages or 2.3 messages? I hope you are not trying to get rid of those, but to work also with them with their file performance. I don't know. I'm not.
You mean what?
I don't speak English very often, so
I think the question is it when we designed FHIR, did we take a look at an easy way to migrate to get from version 2 to FHIR? Or?
No, not really migrate, but more like do you plan to work with them, with the existing HL7 version 2.0 framework, so that it stays basically, but at the same time operates with FHIR, basically,
Right.
profiles.
Right, so that's not migration, but having them at the same time.
Yes.
Yeah. Okay. Yes.
Interoperability between these two
Would it be able to write tools that run both V2 and FHIR and communicate between the two, translate between
Yes,
the two maybe?
yes, and also at the same time, like build on those two frameworks at the same time. You want to do
Yeah.
integration.
So, no, in one way, FHIR is a totally different technology than version 2. Version 2, for example, was message-based. So you compose a message and you send it to a message server. You can do that with FHIR, but the main usage of FHIR we've seen so far is to build RESTful interfaces, which is a totally different interface paradigm. That gives rise to a totally different set of tools. But what we did do when we designed FHIR is we didn't start completely anew. We looked at version 2 and version 3 and even OpenAir, if some of you are familiar with that. We looked at all those data definitions. And most importantly, we looked at how vendors implemented all those messages in their actual systems, how they were used. And we based FHIR on that. And actually in all the FHIR definitions in the models, we refer back to version 2 and version 3 and we say, well, this element here, that corresponds to that in version 2. So we did start anew. It is a different set of tools, but it's not a completely different data model. There is mappings between the two. So there's still work to be done if you're a software vendor. There's no automatic upgrade path between the two. People are trying to look at converting CDA, CCDA, or documents to FHIR to do that standardized, but the biggest problem is that there is also probably no automatic translation between the CCDA version 3 document and FHIR because those standards were already used in many different ways. So it's really hard to write a single transform if you want. So it's a breaking technology in a sense.
By the way, I would like to add, I really like your Lego analogy with the HL7 version 3. I think it was the best I've ever heard.
Okay, thanks. You worked with version 3, yeah. Congratulations. So now this here says in-depth components of FHIR. Since I'm in a room full of software developers, this really is not that much in depth. But I want to show you what are the main components of the FHIR specification. The whole specification, the FHIR specification, which you can find at hl7.org/FHIR, is by now quite big. And I think even if you're new, and maybe Miriam can, we have tried to write some introductory pages where we say start to read here, start to read there, but it's quite big. So it's always useful to just go over the main components, so you know more or less what's in the box. The most important aspect, the most important concept within FHIR is the resource. And the resource is the smallest unit of, I'd say, interchange you can do in a FHIR REST API. So, one example of a resource is medication prescription, another is problem, and yet another one is patient. And these are little data models, maybe 20, 30 fields, data elements. And these are defined in the FHIR specification. The FHIR specification contains about, I think, 110 of those. These are completely documented. There's an XSD schema for it, a JSON schema, and so on. And these are the little blocks that you can send one by one, the smallest unit of exchange between two servers doing a FHIR exchange.
Sorry.
Yeah.
One small question, maybe stupid question now, but
Ah.
is it mean FHIR is like REST API specifications? Which
So-
is built on the top of HL7 standard.
So FHIR is a specification that has data models like this. So we define little data models,
Uh-huh.
and these data models can then be exchanged using REST. That is, across an API, one by one.
Yeah.
But in version 2, of course, you had the message, and in version 3, you had the document. It is certainly possible to compose these little blocks into bigger things. So into full documents that are exactly the same things as CDA documents, or are exactly the same things functionally as messages. So we start at the bottom with a definition of little data models, and these can then be used to create documents, messages, or exchange them on the REST interface one by one. Or you could create you can use SOAP and use this as a payload.
Yeah, but you are speaking a lot about REST API.
Yeah.
How it related to the REST API to the FHIR specifications.
Yeah.
So I understood they use additionally to the specification resources, like decomposition and so on. You are also specifying the REST API, how it should look like.
Yeah, we specify. So this is the first bit in the box, the data models. But on top of those data models, and we have a fully written out REST specifications that show you how to use HTTP to communicate this data across systems. And there all the gory details are byte order marks, MIME encodings. All those details are in the FHIR specification. It's truly a developer-oriented specification that goes all the way from the abstract models here to the bits and bytes over the line.
Okay.
And we didn't have that in version 3. In version 3, we had the colored pictures. And maybe out of that came XSD schemas, and that's more or less where it stopped. Then how would you actually send data? Well, then only the CDA standard is more specific there, but FHIR really is all the way down to the bits. So that's why we can have connectathons, just giving people the FHIR specification and then expect them to show up, connect their systems and to work. You can only make them work if you describe the REST specification too. But first back to the models. How did we make these models? As you can see, I showed them in Lego here as half-finished blocks. It's important to realize that we expect no single system to be able to work for 100% just with what is in the base FHIR specification. On the one hand side, the basic FHIR specification and data models for medication, prescription, and problem, and so on, will have too much data. Like patient will have 0 to star names. Many systems have only one name for a patient. On the other hand, we will have too few data, because every single use case has requirements that you cannot think of if you're making a centralized specification, that you shouldn't. So these blocks, as we say, cover the 80%. The 80% of that data, that 80% of the developers that work in a certain, the work of medication prescription would need. And to do that, we received so much feedback from real vendors saying, well, I'm still missing this, or we also did it the other way around. We presented them with everything we had in version 3 and version 2, and then said, which of these elements are you actually using in your systems? And they say, well, no, we don't use that, we don't use that, we don't use that. So it's very easy to make a very big standard. It's much harder to keep that core small. So we start out really small, cover the 80%. Unit of exchange, I talked about that. So that's a resource. If you go to the FHIR website, you'll just find a whole list of these. I think I have an example here. So this is an example resource. All the resources in the specifications look the same. It starts out with the scope. When would you use this resource? When wouldn't you use it? For example, we have a resource called practitioner, which is of course your doctor. But a guy working in healthcare, a system administrator, or a cab driver that drives around patients, is that also still a practitioner? That's why the first part of every resource in the documentation says, this is the scope of this resource. That's followed by a picture, a UML picture in this case, of the data that's inside. And then if you would click on any of those names, you would get the exact definition of what these elements mean. And below on the page of every single resource is a way you could search through these patients on a RESTful interface. So that's the first part of the description. Patients, obviously, you can search on name and address, birth date. And so we predefined the way you can search for patients on the FHIR REST API. That's, of course, having in mind that many systems will have an actual database below it that is only indexed in certain ways. We could define a specification where you can search through resources in all kinds of ways, but that's not really realistic. We didn't only look at the data, we also looked at behavior when we made the FHIR specification. Which are the normal ways systems allow you to search through data? So we put that in the spec as well. So these models aren't always just simple flat stuff. Here's a patient, for example. It has some nested components like information about what happens if this patient is an animal, or 0 to star contact persons for the patient. So this can be a sizable block of stuff. And also the data elements, they don't use always primitive types. This is here Boolean, yeah, that's true or not. But name is here it is using a thing called a human name. So FHIR has resources, and these resources are built onto a limited set of data types that we have also designed. They are inspired and based on, you could say, ISO 21090 for those who are familiar with that, but much more simplified. Important to point out is that every single resource doesn't contain, so this is patient. And a patient is, of course, part of an organization. It's patient at a certain organization. But the data of that organization is not within this patient resource. Here, I have an element called care provider. I think it's being renamed for the last version. And that points to another resource, a practitioner or organization somewhere else. So FHIR resources are connected by pointing to each other, not by nesting data into one big thing like version 3 did, where everything was in one big message or one big document. No, we allow you to just download a single patient and then follow references. So, as you can already see, as I said, name here, 0 to star, 0 to star identifiers. In many ways, maybe the FHIR resources are actually already too much for what you need. But in many other ways, they're not enough. I already said so. So, what we also included is a way to extend the FHIR data model using things that are called extensions. Examples of extensions are, for patient at least, things like citizenship, mother's maiden name. IHE needed this one for PDQ. US core race. If you look at patient, there's no information about race or religion. Because in many jurisdictions, that's just not what you collect with a patient. But in the US, collecting race and religion was normal in patient administration systems. So when we showed this, many people in the US reacted like, oh, you've forgotten about race and you've forgotten about religion. No, we didn't forget about it. It's just if you really zoom out to international level with your specification, there won't be race and religion. So these are typical areas where you would say, we take this out of the base specification and other people can add on top of that extensions. It's not always about data. Sometimes when you write software, you just have some bits of data that you need to communicate that you don't want to standardize. You just need to get them to the client. And I have an excellent example from a project I did recently in Norway, where they were writing an appointment patient portal. In Norway, you can change your appointment with your doctor online using a centralized national portal. Now, there's also an appointment resource. The appointment resource worked very well communicating data about appointments, but what they also needed is a way to say to the portal, well, some appointments can be changed online, but some appointments can't, because there's a whole business process behind it. You have to call your doctor to change that appointment. Well, this wouldn't show up in an international data model, but still, if this is your use case, you need to be able to send every appointment you send out to the portal as a system, you need this bit saying, this can be changed online and this can't. And FHIR allows you to easily put this kind of extra data inside the data models. So sometimes it's really about fundamental national data, these extensions, and sometimes it's just about data that you need for a specific use case. Both are enabled by extensions in FHIR. And we think there's no choice. You can't make a data standard that covers everything internationally. It's not only about data. If you look at marital status, that is also, so it's the society who defines what kind of codes there are for ways people live together. There's no way you can define it on an international basis. So everyone needs extensions. That's why I depict the FHIR resources as these half-built blocks. To get there, it certainly helps if instead of starting with these very flexible little things, to start out with these blocks, these resources. But to get there, you still need these extensions. Although extensions are, of course, a possible source of chaos. Because if everyone uses different extensions for the same things, you won't have interoperability. We try to solve that by building a registry where everyone who thinks of something smart, a smart extension, can register that extension and say, I already have an extension for hair color, I already have an extension for maiden name, I already have an extension for company acronyms instead of a full name. What's the acronym of a company? So we put these in the registry so people can reuse them instead of creating their own. This slide just shows what I already said, that these resources exist somewhat in isolation. At least on the REST interface, you send them one by one. But they do point to each other. So a procedure has all kinds of reference to other resources to compose the whole story. It can certainly, a procedure can point to the encounter that the procedure is part of. The subject, the patient that is there, maybe a report that was produced during that procedure. All interconnected by these references between resources. I think by now we have a whole set of resources that can cover most of our clinical stories and clinical scenarios. Initially, of course, when we published the first version of FHIR, we concentrated on observations and all the basic things. Now in our last versions, we've added workflow, clinical decision support. I think by now we have the whole story ready. So you take this clinical scenario, you map this data onto our resources, and all these single resources, and then you build them together by referencing them. Now these things can then be requested one by one on the REST interface, but they can also be combined into a single document, for example, to a transfer of care. The same links would still exist, but you would just send them in one bunch and send them across the wire as one document, sign it off and saying, yes, this is a document created by Dr. X for this and this doctor, signature, up, and you have a whole bunch of resources. But the fact that these things refer to each other also means that your data could be distributed across multiple servers. Architecturally, this is certainly possible. You could have, for example, a lab system here on the right-hand side with a diagnostic report. A diagnostic report in FHIR itself is also just a packaging mechanism saying, hi, this diagnostic report was done on that date by that and that performer, and it contains 0 to star observations that are the actual result of a diagnostic report, but it refers to them. So these two resources would probably be, in this case, on your lab server. But it's certainly not necessary that the patient that is associated with that diagnostic report is also on that same lab server. You could have your patient registry in your system. And this would be referring to that system because these links are actually URLs. You could follow these URLs, get to this server, and then ask for the patient information. Likewise, we can do the same thing if you'd have a practitioner registry, maybe a national, who knows, a national practitioner registry. You could just point to that national practitioner registry instead of having all the data on your own server. These are possibilities. I'm not saying this is the way to do it, but FHIR enables you to connect resources that way. So virtually, a FHIR server, the REST interface on the FHIR server, represents medical data as bunches of resources, patients, orders, and so on. And as a client, you communicate with that repository by saying, create a new patient, create a new encounter. These are the RESTful statements. Much more interestingly, you can query all these resources in certain ways. I showed you I didn't show, but I tell you, every resource page has kind of search parameters to search through these resources. So you could say, give me all new lab orders that came in. Periodically query these from the FHIR server. And then if you have lab results, you can post them one by one as resources back to the FHIR server. FHIR also has a subscription architectural system where a patient system could subscribe, for example, to things happening here. So if a new lab result comes in, you could pull every 5 minutes or every day, but you could also subscribe to changes and receive notifications that a resource had changed on the FHIR server. I'm not saying that a FHIR server should actually physically have these tables or these things internally. It could have their own database, but logically, this is what the REST model, the FHIR REST model represents. It's kind of repository model of healthcare. To get a little bit more in detail, as I said, all the links in FHIR are actually HTTP links. So to get to a patient, you go to FHIRserver.com/patient/123. That's a single patient, well, 123. But you can also go to a FHIR server and say, give me encounter 904 and include the patient data immediately. Because otherwise what I would have to do is you send me and return me this encounter, but I need the patient data too, so well, I would have to do a second query on the REST interface to say, and fetch me the patient data from that encounter. The FHIR API allows you to query both at the same time. So yes, the FHIR specification documents exactly what the REST interface looks like for this. Of course, the put here, that's the change. Not only can get data, but servers may allow you to update data by sending a resource. And finally, as I said, I think we're missing the bottom part here a little bit. You could put combinations of resources into whole documents. We call those bundles. Combine a whole set of resources and return that from a server. And Miriam will get into more details about that. So though I have been talking about REST for most of the time, because this is what differentiates also FHIR from our previous specifications, and I think that's also what makes a lot of the newer cloud-based and app technologies possible. Yes, FHIR provides also ways to compose these single resources into bigger things like documents. I'm going to show you that for a little bit. So I have two resources here, two medication prescription resources. And FHIR provides a few resources out of the box that you can use to combine resources. And one of those is the list. This is a list resource, and it is coded to be a discharge medication list. So the list resource is a code, and you can use a line code or whatever and saying, these are actually discharge medications. And this list will then point, by reference, to these medication prescriptions. Likewise, we could have a set of vitals. These are encoded as observations in FHIR. Again, this is a code, maybe a SNOMED code for pulse or blood pressure, and a value with the actual value of your blood pressure measurement. You can have a list of vital signs, coded to be vital signs, and point to them. And now here's the magic. We have a resource called composition. And composition itself does not contain data, but you'll probably by now recognize the pattern. It will be able to reference again to other resources which are part of that composition. So if we want something like a discharge summary, which is really not a single resource, but a document, we can use the composition resource. The composition resource contains sections, so we can put our document nicely into human readable sections. And these sections will then point, for example, to these lists. So this way, we compose what would otherwise be just a flat, big list of resources into a logical document. Composition can point to conditions. Of course, it will point to authors and subjects. And again, none of these need to be in the document. You could say, well, I want these resources to be part of the document, but these references, you would just have to go out to our provider registry and find it there. However you do it, you bundle these into a resource called bundle, which is also a resource again. And a bundle is a very technical resource. It has no medical content. It's just there to load up a whole bunch of resources and contain resources inside that resource. So in the end, everything is a resource, but this is a pretty big one because it represents a whole document. An important detail is that whether you build a document or build a message or work on the REST interface, you're continuously using the same resources and the same definitions. A patient resource or a prescription resource inside a message or a document is no different from the same thing present on the REST interface. So you could extract data from a document and make it available on the REST interface without changing it. It doesn't sound surprising, but this was absolutely not the case with version 3, where the people who designed the document stuff in version 3, CDA, for example, designed the medication models in a slightly different way than how medication were used if you were to use messages. For vendors, that's not such a nice thing, because then depending on how you send the data, you need to map your data differently to the output model. So in FHIR, we made sure that whether you're sending a FHIR message to a server, then update or look at it using REST, and then maybe combine data there into a FHIR document that you send to your national exchange, the contents of these things, regardless of the paradigm, the contents of these exchanges are exactly the same. The definitions don't change. You go to the patient page in the FHIR specification, that's where you'll find what a patient looks like. Are there any questions about that? Yes?
About namespaces, do you reuse the standard namespaces, or do you have your own?
And which are the standard namespaces, for example?
Well, for example, CDA R2.
Can you repeat the question?
Yes, I will repeat the question. So the question is whether we are reusing namespaces. So this is XML namespaces,
Yeah.
right? Yeah. No, we don't. FHIR models are, the FHIR is a breaking technology compared to version 3 and version 2. So version 3 had, of course, XSDs as output, right? If you used the version 3 tooling, you would get XSDs as output, but they were never, let's say, a core product. They would just be, actually, they would be different if you run a tool later on, or they would change. I don't know if you work with version 3, you would change all the names of the elements inside. So version 3 had the idea that you shouldn't even look at namespaces or even the names of elements. You should look at the class codes inside and all the structural elements. So the tools had the freedom also to just regenerate XSDs and rename all the elements inside. So even if we wanted to, we couldn't. But it's also true that the way FHIR looked at data is actually comparable to how version 3 looked at CMETs. So we took the CMETs from version 3 and turned them into full things. But our definitions are so different that we're not reusing any of the XSDs, if you could already say that XSDs from CDA, for example. It's a breaking change. Yeah.
Are you going to talk about profiling?
Yes. I think that's on the program for the session after the break, if I remember correctly.
One question about the stability of the things that you showed so far. You already mentioned for some of the contents of resources that there are small changes, but talking about most of the things that we haven't seen so far here, how stable are there? Are there likely to be big changes between what you showed and the next versions?
Yeah, I will go a little bit more into detail, I hope this afternoon or later after the break if we have time for that. But you can imagine that the resources we defined first in 2011, 2012, they have had a lot of feedback. So resources like patient and organization, by now they had hundreds and hundreds of feedback on them. So they are pretty stable. So a resource like patient, that won't change anymore. No, not much. But FHIR grows and new resources keep being added, and those are new. So the ones we added maybe 18 months ago, they are certainly less stable than the ones that were there already for some time. But it's not only the resources. If you look at the REST specification itself, the way we use XML, the way that we use JSON, the way our RESTful searches work, those things have been around for quite a long time, and they won't change a lot anymore. But some of the more experimental things, some of the more newer things, they will still change. Now you might be wondering, how would I know which parts are stable and which parts are not? And the FHIR specification actually has this marked on every single page in the FHIR spec. You will find a maturity number, 0 to 5. 0 is most definitely this will still change. 5 means, well, if this has to change, man, something really earth-shattering would have to be, we really thought a long time about this. We're pretty sure this is stable. So you could look at these numbers to get an idea.
Now just questions about the compatibility between different versions. Like for example, I develop system using the latest now your current versions. What will be next? For example, if you develop new versions and I just finish healthcare, you take your new versions. How will be compatible our system now?
So far we've been. So the question is, sorry, how do you handle backwards or forwards compatibility?
Yes. Yeah.
And the answer at this moment is we don't, because our current versions are all alpha. We call them draft standard for trial use. There's the word draft, there's the word trial, and it's meant to say here. Please comment back so we know what to change, but it also means that we're still changing stuff. So to be perfectly honest, our current standards are draft standards for trial use. So we allow ourselves to make breaking changes. I told you about this maturity number. Certainly things that are on 4 and 5, we don't change them that much. We do look at backwards compatibility. So even though our specifications current are still trial use, so we can change everything we want, doesn't mean that we would do it everywhere. Resources with these lower numbers, 0, 1, 2, 3, 4, yes, we'll just change them. But more and more, so the next quarter, 2017, say April, we will publish a version called STU3. And that is the last, that's at least what we now think, that is the last version of FHIR that can still be changed, that still has resources that can be break backwards in compatibility, make changes. The next version, which will probably is the first normative version, we might call it revision 4 or version 4, will contain normative content. And normative content for a standard development organization means this content we won't make changes that are backwards incompatible. But that is 2018 timeframe. So for now, my answer would be yes, we allow ourselves the freedom to change everything we want, though with the resources with these higher maturity levels, it's pretty unlikely that we will. I think it's break time. Huh?
Yep, it seems we are break. So we are going to have the break until 10:40, which was the original schedule. So thanks for so far, and let's get back here by 10:40. Thank you.
So, welcome back. I will now return to the issue of profiling. I've referred to profiling a few times already. Once when I showed you that whole scala of very flexible all the way to very specific. What am I doing wrong?
You're moving around too much.
I'm moving around. Oops, sorry, it was home, sorry. Okay. So, the FHIR building blocks, the resources, they are somewhere in the middle of that whole scala of flexibility. But to actually build things, I already said, you need to make these blocks more specific. So, the FHIR resources have lots of flexibility, and for every single use case, you need to be able to describe the adaptations based on use and context. So in the context, for example, of Finland, you would like to say, well, a Finnish patient doesn't have 0 to star identifiers, but maybe 2, of which one is the national patient identifier. And that's called profiling. So you're going to take the freedom of the FHIR resources that are in the box, you're going to limit that, on one side limit that flexibility, remove the things you don't need, and add maybe extensions. Right? We're talking about extensions. And you describe these, and doing this is the act of profiling. So, in any solution, in any national solution, maybe in the context of a provider registry, which resources and elements in these resources are actually in use? It's a ways to say, well, just implement everything, because that means that every single system that works in that context needs to implement all kinds of things that you will never use. If you never use 0 to star names, why keep it open? Well, sometimes I have some colleagues and people working in standardization say, well, if I keep it open, flexible, then I can, I'm not forcing anyone into one kind of solution. We can use it that way, and then later on if we think that was the wrong way to do it, we can still use the other way. Yes, that's very flexible, but it also means, again, this is the whole discussion. The more flexibility you allow, the less systems will be likely to communicate out of the box. So when you start making profiles, you have to wonder about how specific am I going to be, to enlarge the chances of systems being compatible, and how much flexibility will I allow. Which API features are used? Many times when I talk about profiles, I must admit I'm always talking about the data. So I'm taking out this element, I'm doing this. But the FHIR API in itself is actually much the same like the data. We have described lots of ways to search through a patient on the REST interface. But maybe for your use case, you don't need all of them. So if you write an implementation guide as a standards development organization, or you write an implementation guide as a vendor to say this is how we implement the FHIR, you should be able to say, I didn't implement all those search operations on patient, I implemented this one, and this one. So profiling also tells us of all those features in the FHIR specification, which one are of use in our use case. Which terminologies are we using? The FHIR specification tries to define sometimes a set of value sets, and it says this is the only values you may use on this spot. Just a very few places where we do that. In many other places we say, well, we have a suggested list of things to do here. Marital status, divorced, married, single. That's a set of codes we have, but we also understand that in many jurisdictions you will have additional codes for ways of how people live together. Those things change from country to country. So by profiling, you can also say, well, in our context, in our national context, or in our context, anyway, we have different codes or additional codes. Finally, profiles can tell you how this maps to local requirements. So how you could say in a profile how this data maps to version 3, or how your codes map to codes in Loink. Profiles don't exist in isolation. If you make a profile, the first step is, for example, you profile it on the base specification. So if you make a profile on top of patient, you're saying, I'm taking the basic definition of patient and limiting it and extending it a little bit. But you don't have to stop there. You could write profiles that take other profiles as input and say, I base my profile on a regional profile. You could have, for example, a country adapting a national profile. So this is directly on the FHIR resource, and it profiles FHIR practitioner, FHIR organization, FHIR patient. But if we look at regional, we could say, well, or in region, or certain specialities here, certain medical professions, they may develop even more limited profiles that are compatible with those, but limit some of the aspects. So everything that's a valid organization here is still a valid organization there, but it has extra constraints on it. And then finally, the bottom, maybe you have specific use cases where you say, and I'm going to limit the specification even further, because now I'm talking about one specific use case, so I can take away all the flexibility and say, well, for this use case, this is the only way you can use FHIR. These can be stacked, layered on top of each other, so that everything here is compatible with the more generic version, is compatible with the even more generic profile, and then finally is compatible with the definitions in FHIR. Any questions about that? Because we often have discussions about what should we do if you look at FHIR as a country, as Finland or as the Netherlands. Which level of profile should we try to go? Should we go to very, very specific profiles, so everyone, should we start out there? And then, I personally think that initially it would not be a problem, as I said, to do this kind of bottom-up standardization. This is where you see the bottom-up standardization. Vendors in a certain specific area of interest can use FHIR and develop very specific profiles. And then when these two need to communicate, so I showed prescriptions in cancer hospitals and prescriptions for GPs. They might define very specific profiles. But when they need to communicate together, you're going to step back and say, hey, where do these align? If they don't align, let's align them. You're actually going to develop a set of higher level profiles that describe the commonalities between these lower level profiles. And this is certainly a way to realize that bottom-up standardization. If you start out with very global profiles, everyone will just implement them in all kinds of ways anyway. So you're not gaining anything, you're not getting feedback. If you start with very specific profiles, people will say, oh, I can't use this because I can't have multiple addresses on this patient, and I really didn't need that for my use case. This way you can start a discussion and develop more flexible profiles that allow, for example, multiple addresses, because there is a real need. If you start from the other side and say, well, we allow everything, you will always have agreement, but you will also never get there. So some specific examples of constraining a resource. Patient in the specification. A very common demand is the patient identifier should at least have the national patient identifier. These are the kind of things you can say in profile. Limit human names to just 1 instead of 0 to star. In fact, during the FHIR Developer Days 2 weeks ago, we took a good look at this, and do we really need 0 to star names? This is actually there because you could say this guy has or this girl has a VIP name, and it has a real name, artist name, real name. Is it really a use case we want in that 80%? But still we have 0 to star human names. Marital status, I talked about it already. So for marital status, if you encounter this in a resource, we say, we as HL7 International thought up a list of ways that people live together. Marital status. But marital status is certainly, you might want to both limit, so remove codes from it, because they're not of use in your patient administrations, and add codes to it, because you have administrative codes for people living together that didn't make it into the international standard. And finally, of course, and I'm pointing to the bottom here, you can add extensions. You can say, any patient communicated in a Finnish context needs to have these extensions. Or you could say, you need to know that you can expect certain extensions. So if you look at human name, in the Netherlands we have defined extensions on human name, because in the Netherlands a woman maintains her husband's name in her family name. Well, that's a very specific, well, it's not really specific to the Dutch, the Germans do so as well. But it's quite specific, so that didn't make into the international standard. But in the Dutch context, we say, you should be expecting extensions on human name. I don't think you would do that in Finland. You'll also notice that most of the cardinalities here are 0, because whenever you try to make something mandatory, someone comes up with a use case and say, well, in my case, I don't have a human name. Oh, okay. So more and more, we went to 0 in the cardinality here. And of course, for specific use case, there we go again. You most of the time will make things mandatory. You will make identifier mandatory. So what is this profile? Well, you could write it down in a Word document, right? We've done it before. Some people do it that way. Smart on FHIR, for example, has a lot of profiles on FHIR, and they do it. They wrote it down in human text. That's what you can do. We did that in version 3 as well. In CDA, you had bunches of PDF files, shell contain shell, and so on and so on. Works. But if you're familiar, for example, with OpenAir, and I know that it has use in, I know it has use in Sweden and Norway. I actually don't know if OpenAir is a theme in Finland. Does anyone know about OpenAir? A little bit, yeah. Well, what they did is they piloted computable forms of a profile. So all those constraints, change the cardinality, change the values, say do this, do that. You actually wrote it down in a form that is readable by a machine. The advantage, of course, is that then machines can check your data against that and can validate the data that you sent across. And OpenAir did that. They developed something called an archetype definition language, which is, in the end, a bit of data that a computer can read. And we copied that approach in FHIR. And, because we already had the resources, we actually have a resource that contains a profile. So this is kind of a circular thing going on, where we have a resource called structure definition that describes how a resource called patient looks like. Or that describes how your constraints, your national constraints on the patient, what they look like. There is a resource definition, there's a structure definition that describes the data elements in structure definition. But the good thing is that if you know how to communicate the patient using the REST interface, you know how to communicate the structure definition, because it's the same technology. So a FHIR server could serve up structure definitions and then ask, and then literally act as a RESTful interface to a national registry of profiles. And this is, of course, what we do with our community server Simplifier, which is also a profile registry.
Just one question.
Yes?
Do you use the ADL as is, or did you just copy the concept?
We copy the concepts.
Okay.
Yeah. Yeah. We still like to say that we can translate ADL to structure definition, because we took a lot of those concepts. We were really inspired by what they did and copied those concepts over. Yeah. So, if you're interested, the FHIR specification contains a zip file with all the structure definitions describing the FHIR specification. And this is handy if you want to do code generation, for example, and many parts of our tools are based on these definitions. So if some committee changes the definition of a profile of a resource, we run the tooling and we have a new version of the documentation. That's being done based on structure definition. There is a chicken and egg problem there, of course, but that is about, structure definition is about constraining data. I already said you can change the API as well. So, we describe in the specification exactly the FHIR REST, how you do read, how you do update, how you do search. That doesn't mean that you can't extend it. You can actually add complexer operations. Read, update, search is nice to do kind of CRUD behavior. But there's always more complex operations. Examples, we have a validate operation. You can go to a FHIR server and say, I have a bit of FHIR data here. I have a profile. Can you validate the two against each other? That's the validate operation. We have an operation to work with terminology, expand value sets. I won't go into terminology here, but we thought that terminology could be way more popular than it was. Terminology was something that was hard, and we wanted to make it easier and more approachable. So we not only have a resource called value set that describes the set of values that are valid in some context, for example, for marital status, but we also have operations to work with these value sets. So you can ask this code, is it in this value set? That's an operation. And you can define operations yourself. Checking drug interactions, merge patients. Not all of them are in the FHIR specification. The terminology ones are, the validate one is. Again, here there's operations in, you can expand that yourself, you can change the API. So this means that we don't only have medical information resources in the spec, but we have a whole set of resources that describe the API and describe the data. We call these things the conformance resources. And together, these conformance resources describe your use or your implementation of FHIR. So together, they form the basis for an implementation guide, which is maybe a human readable document or a website where you can send developers and say, if you want to cooperate in, say, again, maybe a service provider directory, go to the service provider directory implementation guide, and there you will see how we have defined provider, how we've gone about, how we did the structure definition for the Finnish or the Norwegian, the way we partition it, which value sets we use. Operation definition, you can define your own operations, you can even define your own searches. One example of a search which we did in Norway was there's a national identifier for care providers. This could be doctors, it could be organizations. So we needed a search where you would give this number and the FHIR server would return a list that could be organizations, it could be practitioners. That's not a standard search in FHIR, so we defined a new search parameter for that. Concept map is a resource that describes the relationships between two codes. Maybe one is in LOINC, or maybe one is in your national terminology. Another one you map it to LOINC. You could use a concept map resource to say these two match up in this way. This all set together describes your use case. So to write them, well, you could use it by hand, right? All of these are JSON or XML files, but the community is developing tools to help you write those. So initially we used Excel as a source, kind of a source editor for the structure definition, but some of you will have met an editor called Forge that is a visual editor to make structure definitions. There's not yet a visual editor really for concept maps and naming systems. Luckily, these ones are much simpler in XML form. I don't mind writing a value set by hand. Others might, but it's doable. Search param definitions, I just write them in XML. Servers. So you could use these resources to define how a use case behaves. But servers can also use it to say, well, this is how I implemented the FHIR specification. That's the other side of the story. So you can use this to sort of describe requirements, how to use FHIR. But you could also describe it to publish capabilities of a server. A server can say, I implemented patient in such and such a way. It would be interesting, and in fact, I still hope I will get one of the students to work on it, that say, I take the conformance, I take these conformance resources published by a server that says I am implementing FHIR this way. And I take a set of these conformance resources from an implementation guide and that say if you want to be a provider directory you need to implement FHIR this way and compare them, and then you could actually compute whether these two would be compatible or not. If an implementation guide requires you to have 0 to star names and the server publishes in its conformance statement the structure definition say, but what I implemented is a patient with one name, you can see problems coming. In theory, you could compute that. We're still waiting for people to actually write that, but you could do it. Now, that's all those computable artifacts. If you add to that functional requirements, or really human readable text, examples, security, you would get to an actual implementation guide. Describe your national requirements and so on. Put this into a tool and generate implementation guides. Over the past few months, we have invested a lot of effort in this technology. So once you've gone through the trouble of authoring and writing profiles, the benefit would be A, that you could publish it on a registry so people can find it, and I know this is what's happening in Finland. We'll maybe hear about that a little bit at the roundtable. From those things, you could generate an implementation guide that is used by developers to implement the FHIR specification, to implement that use case. And then these computable specifications can be used to validate and test certain implementations. So there's a lot of reasons why you would want these computable expressions of a profile. I'm not saying everyone is doing it, because it's still effort. It's easier, it's just like documenting your software. No one really likes to do that. It's easier to just write it. But if we make enough tools that, for example, do code generation based on profiles and all these publications, we can make it attractive to at least write these profiles and then publish them, for example, on the Simplifier FHIR registry. Are there questions about that?
What does that mean for FHIR app that, for instance, tries to work internationally in as many installations as possible? Do we then need to say in the app, okay, in this installation I use Finnish blood pressure or Finnish blood glucose, so they profile observations, for instance?
Yes. This is a very fundamental question. The question is, what does it mean for apps if we have all those freedom and those profiles? Could I make an app that says, I go to a server and it says, which profiles do you implement? Okay, I change my internal logic to implement your way of using FHIR. Personally, I think what's going to be really interesting is what the big market forces do here. So, if say big American vendors like Epic and Cerner, which they publish across the world, and they will probably implement FHIR in some consistent way. If I'm an app developer and I'm looking at the biggest market, what would I do? Probably look at how they did it. Not what HL7 says, maybe not even what HL7 Finland FHIR says. How did Epic or Cerner do it? That's what I want in my app, for sure. It doesn't need to be the only one. I could do a little bit more flexibility. There have been app developers saying, well, it's not that hard for me to implement 2 or 3 different code systems. There needs to be a limit. You can't build all the flexibility of the world into an app. So I think market force is going to be very, very interesting here. Who are the major players? So if you turn the thing around and you look at if you were to be Finnish standardizers, so you're working on standardization in the Nordic countries, for example. When I talked about universal standardization, it's for sure that the more you coordinate your use, say for example of PHR data across borders, maybe within Europe, you get to be a bigger market force. You could say to the big vendors and say, well, this is how we do it in Europe, you better build it into your software. But the larger the number of countries, remember my first slide there, the less the chances that you actually will agree on something. So this is a really difficult position that a lot of countries are in. If we are going to make a national profile, it will be maybe somewhat easy to make, then including our neighboring countries. But then you won't have the market power to say to big vendors, implement this in this way. So I think in the end it's going to be interesting to see what the big vendors do. So these are the slides where I'm going to tell you a little bit about the future plans. And this is, I talked about it, the DSTUs. I'm going to put that a little bit more in context. It was just before the break, so there is no problem to rehash this a little bit. Where did FHIR come from and where are we going to in our publication phases? Standardization is a slow process. It's always slower than many developers would like it to be. I told you we are open. We are open for requests for comments. People can ask us to change things. But I once talked to a guy from IBM, and he was for the first time at an HL7 workgroup meeting, and he said, "This is going so slow. 2 weeks ago, I put this request for change, and still we're not talking about it." So, well, no, this is not really the kind of time frame that standardization organizations are operating on. We consider ourselves way faster than before. You know, we don't take a year and a half anymore, but it still takes time. So I want to be clear on the pace of things within FHIR and within HL7. I think if you look at the speed FHIR has been developed since, say, the end of 2011, for standard development organization, it's lightning speed, really. But we are still we're still in the draft phase. So the first draft, somewhere end of 2011, 2012. I think January 2012, San Antonio was the first time we sat together and we had maybe, I don't know, 30, 50 HTML pages. That was FHIR, and we were with 7 people. So we had our first Connectathon. We didn't focus on medical things. This was just, what are you doing with that byte order mark? You're using this. It was low, really low level stuff. That's where we started out. The interesting thing is that it tells you something about how we developed the FHIR specification. Both Graham and I are software developers. So what we did is we sat down, we wrote a bit of the specification, and then we implemented it. That's why there are reference implementations, why Graham has a server and we have Spark. It's not because we found the FHIR specification, we wrote it and then we developed it. No, it started in concert. So this meant a lot of times we would just have written down something, try it for a week, and then on Skype we would say, "Oh, that was a bad idea. That is way too hard to implement," and we would change it. So the FHIR specification was done interactively that way. And then by 2014, we had the first draft standard for trial use. And you must understand that this first draft standard for trial use was really, really a draft standard for trial use. We know there were big gaps, but we also knew that we wanted feedback at that moment. So we pushed it to a certain point where we say, now it's the time to go beyond the first 10 to 15 people who implement it. We will wait and see a little bit about the feedback before we go on and do things in a totally different direction. So please give us feedback. That was the nature of DSTU1. We knew it was incomplete. We knew it wasn't finalized. Still, people started to build software with it, and some of it even in production. That's what happens. Who code wins. This stuff is used in production. We got about 1,200 requests for comments, even on this first DSTU. So by the time we published DSTU2 about 18 months later, we had fixed a lot of problems and changes in DSTU2 and DSTU1, and we added a lot of new resources. Initially, of course, we focused on the basic things like patient and organization. And DSTU2 added things around support for XDS, imaging, DICOM, the more mature things, and fixed a lot of those holes and bugs. So big differences. I would say it's really hard to write a system that does both DSTU1 and DSTU2. Now, going from DSTU2 to STU3, the D is going out. That doesn't mean that it's any more stable, but HL7 thought that it would be wiser for marketing not to have both draft and trial. That sounds so extremely drafty that they said, let's drop the draft. Let's just say standard for trial. It's good enough. we can still, as I said, we can still break backwards compatibility. But you can understand that things like patient, which we introduced back here, by now have stabilized out quite a lot. And the number of changes between these two it's incomparable to the changes between the ES21 and the ES22. In fact, any resource page in the specification, there is a tab that lists the changes between STU3 and ES22. That would have been totally impossible between these two ones. So a lot of maturity added, and also ES23 added even more advanced scenarios like workflows, clinical decision support, genomics. I think I have a list for you all. But it's still a standard for trial use, so it's not normative. And so you could say, well, 5 years, by now shouldn't you be normative? Well, because we value feedback, and we saw how valuable feedback was. It was not by here, end of 2014, maybe somewhere here, that the big vendors came into play, that Cerner and Epic joined us, and they came with 15 interface developers. And not only those, also the national champions in many countries came. So people from the neighboring country, from DIPS in Norway, started to come to the international meetings. So this is when we really got feedback into, additional feedback. So we're not in a hurry. We need that. Still, by 2018, we want to have more or less our first normative version. It doesn't mean that the whole spec is fixed, because things that just got added here in STU3, they haven't had this whole period of maturation that the other things like patient had. So things around workflow that have been added in STU3, they will certainly need more time because they get normative. The things we've added here, by now, they're stable enough to make them normative and to make sure they stay backwards compatible. So we envision doing a normative version and then every 18 to 24 months a new publication where the less stable parts become more stable. So in the end, everything becomes normative, but we do that part by part by part. In the meantime, between these publication moments, this is not a black box process. We have the published specification, so these fixed ones, they don't change. So currently we are at DSTU2. So if you go to HL7.org/FHIR, you will find the situation of end 2015, the publication moment of DSTU2. But if you go to build.fhir.org, you get our nightly build, which is almost there. Every single time someone changes the spec, it goes to our continuous integration server, which builds a new version of the specification. So build.fhir.org has the latest of the latest, and you can just watch and see. So you don't have to wait until publication moment here before you can do the new things in STU3. You can look at build.fhir.org and find out what will change once we go to final publication. And this has moved to, say, March, April 2017. That's important. Any questions about that? Great. So to give you an idea of what changed from DST1 to DST2, lots of, 1,200 requests for change. But apart from that, we added scheduling. We started to work on basic workflows and patient care. Episode was added, communication resource to support use cases. We didn't have them social work use cases where you just wanted to exchange written text of messages between the two. We met with groups after we published DST1. We got lots of interest from, for example, DICOM. So we added resources to the FHIR specification that were compatible with the metadata in DICOM images. We don't represent the images themselves. It's possible to have the metadata and imaging study is the resource in FHIR. We took a look at the 11073, the IHE PCD document, and added device component and device metric to the specification. And for those using XDS, IHE wrote a FHIR version of XDS called MHD. And we added resources, document reference, and document manifest that represented XDS metadata. So this was, you see these two, these were important moments where we started to cooperate with existing standards and adapted FHIR and to be easily mappable to these important use cases. So it's now, well, it's actually November 2016. STU3, as I said, added more advanced use cases. I must say we have more requests for change by now. So STU, again, standard for trial use. It's still trial. So the official disclaimer is, regardless of the degree of prior implementation, so we don't care what you already put into production, is what this says, in a nice way, all aspects of the FHIR specifications are potentially subject to change. We can change it if we want. Let's be clear about that. That's not saying that we will. And so that's where the FHIR maturity model comes in. On pages of the FHIR specification, you will find a maturity level. Behind every resource in the specification, you will find a maturity level. And this really indicates how likely it is that a certain data definition will still change. So level 0 means this is draft. We added it to the spec for first review. Sometimes one committee member that just had a bright idea and thought, let's try this out a little bit, let's play with it. Level 0 isn't saying anything. Level 1, ready for test implementation by pilots. So that means the committee has put some work in it and thinks that you can use it to do things at hackathons and try it out. Level 2 is slightly higher again, and it means that at least some people not being members of the committee, some actual vendors, have tried this stuff out in realistic scenarios. And level 3 is, by now, we've had this first line of feedback from vendors. We've improved the resource. We've added examples. We've made sure that that all the text has no longer to do in it and so on. And feedback resulted in changes. So sometimes this is surprising. What we wanted to avoid is for stuff in the specification to mature to levels just because there was no input. You could say, well, we did not get any feedback on it, so it must be perfect. Instead, the requirement here is, no, you can't proceed to next levels unless someone said something was wrong with it. It's a bit twisted, but we are pretty sure that nothing is created perfectly the first time around. So we require people to have feedback before resources move on in level. And then level 4 and 5. Tested, verified, and stable. Backwards compatibility becomes a priority. From level 4 on, we just want to change things. Level 4, we still will change things, but we will use chat.fire.org, we will use the mailing list, we'll use anything in our power to solicit feedback before we do a change. And level 5, it's so widely implemented that we could consider it frozen.
One question here. Do you support all 3 formats? Presentation, XML, JSON, and RDF, or just recommend to use the JSON in your specifications and implementations of your specifications?
No, RDF, no, XML and JSON is we expect FHIR implementations to implement both, but RDF is certainly not a mandatory option. There is a sub-community of the FHIR users that want to use RDF. And we have given them a way to encode FHIR data in RDF. But there are not many production servers that actually produce RDF.
Yeah, but XML and JSON we support simultaneously.
Yeah.
But from your point, recommendations, is it better to use JSON to implement your specifications? It's like
they're completely comparable. It's really a matter of taste. And it's always interesting to see. For example, the FHIR developer days, you will have this group of people that say, why did you actually include XML in the spec? No one uses that. We're like, well, There's a big group of users that use XML, but these guys, they come from a different industry and they've only used JSON, so they don't really understand. You don't even have validation for XML. So yeah, well, we have everything. We have XSD, we have XSLT, we have schematrons. They don't know. So these are really sometimes two separate communities. Initially, because JSON was not a standard used by, defined by an SDO, Graham was thinking about not having JSON. I was like, no, you can't do that either. There are a lot of app developers coming from a JavaScript corner that won't take you seriously if you don't have JSON. So that's why we have both. But they're completely functionally equivalent. Anything you can do in JSON, you can do in XML. Anything in XML, you can do in JSON. And by now, JSON has its own schema language, JSON schema. So we started to generate a JSON schema as well to do base validation, at least of the JSON data. So we will see the first very mature 4 and 5. Well, I think we might see some 4s in STU3 already, but certainly 5. So normative content in 2018. And then from 2018 we will update, and more of these resources will have higher maturity levels. Questions?
Where can I find STU documents to see the maturity level that you have?
Yes. So if you go to FHIR.org, for example, of HL7.org/FHIR, you get to the current DSG2 specification. There's a link, resources, on top. If you click that, you have a whole list of resources, and there's these little numbers just next to it. Those are the maturity levels. And if you go to build.fire.org, exactly the same thing.
This is for the current version.
Yeah, this is for the current DSG2 version.
For the one that you're working on.
Build.fire.org has the...
Can you repeat?
Build.fire.org.
Can you repeat the question as well?
Oh, sorry, yes.
Yeah.
Sorry. Build.fire.org. The question was, where can I find those maturity levels? Well, to be very precise, if you go to any of the versions, so either HL7.org/FHIR, which is DSG2, or build.org, build.fire.org, there, and if you click on resources, you get a list of resources, and then next to the name of the resources, you will see a little number, and that is the maturity level.
But perhaps you can show them the website where you can find all of the versions of FHIR. Is that possible?
All the versions of FHIR, yes.
Yeah.
Build
Just go to the FHIR, the official website, and it's on the top of the homepage, so that's a nice one to show.
Wow, that's not really readable. So this is build.fire.org, and this yellow box is warning you. This is the continuous integration build. It will be incorrect. It will be inconsistent. See the directory of published versions. If you click on here, you will see all our fixed versions that we have. So you see that DSTU2, the official version, was published on October 24, 2015. And we are now in STU3 cycle. You see multiple publications, and we do fix even our work. We do fix it now and then. So even though we have not published STU3 yet, we have certain publications within the STU3 cycle, and these happened just before connectathons. So December 3, 2015, we fixed it so people could work on it for the January connectathon at the workgroup meeting. March 13, 2016, we fixed it for the May connectathon, and so on. August for the September connectathon. So very soon we will see a fixed version for the January 2017 connectathon of STU3. And then, of course, I hope somewhere in April we'll get the final version. So I need to tell you something about these maturity levels, because so if I go to resources here, Here are those numbers, and you'll be shocked to see that many of those are 0 and 1. And I've been telling you all about how stable stuff is getting. These are not the final numbers. We will update these numbers only just before publication. Yes?
I was looking for, but I couldn't find, so is there like a place where I could find like reference implementations or test results or to see which, because of course when you go into real life and have results from that, you can establish that the standard is a lot more mature. So where can we see stuff about this?
See if I understood your question correctly. Test results, maturity. Yeah, well, there's a lot of detail here. So the question was, where can I see more detail about, what I understood at least, where can I see more details about the process of determining the maturity level and tests and outcomes? That's actually not a single place. But if you click on these numbers, so I click on the 1 here, you see documentation of all those levels, and there is actually a link to quality guidelines, which describe all the quality criteria we have set for each level. And then there is a link to a tracker spreadsheet. And here you can see by detail how each committee is judged and how we have determined the current maturity level. But that just this is the final. So we will do this examination just before publication, and this will determine the final maturity level of those resources. But if you want to really have a sense of what kind of comments come in, there we have our tracker. This is on GForge. This is the issue tracker, the FHIR issue tracker. And well, I need to log in. Anyone can get a login, by the way. And then, for example, I can say, so the care team resource, what's going on with that? Just removing all the filters here. If you browse that, you see that the care team so far has had not much, in this sense 12 requests for comments. So it's interesting to review these and see where is this heading, what's happening with the care team resource, which is one of those resources that are pretty young.
Yes, as a project manager, I want to know if we are taking into use something that somebody already has running in production,
Yes.
or are we the first ones to test it? So
Yes.
of course the risk is completely different.
So if you want to know whether resources with a maturity level lower than 3 have not seen, as far as we know, any practical implementations. And if I go back to this Excel sheet, we are tracking the first implementers. So to ask your question, here is a rows with production system 1, 2, 3, 4, 5. We do keep track of each resource of the first 5 systems that we know of that have been implementing that resource. But we don't know everything. That's the point. The people are working with the FHIR specifications outside of the team. We know about the people that reach out to us. We know about the people that are on chat.fire.org, our Skype-like communication platform. But otherwise, we don't know everything either. It's our baby, but it has grown up and it's left the house, more or less. Oh, it happens a lot that people come to me. I had it the most. One of the things that surprised me the most this year was in May. I was at HIMSS, and in HIMSS there's suddenly all these producers that say they have implemented FHIR, and I've never seen them on any communication channel. And it could well be true, because of competitive reasons. You might want to shut up about that and have NEAs. There was a guy from the University of Pittsburgh that said, oh yeah, we're using FHIR inside the University of Pittsburgh Medical Center. We have 1,200 systems and I've converted tens, maybe 100 of them by now by using FHIR, and we never heard about this guy. So we invited him to come over and speak at the FHIR Dev Days 2 weeks ago. And it's impressive to see this guy just operated more or less in isolation. We never heard about it, yet he had done these kind of things. That happens. That happens. No? Well, whatever. Okay. The FHIR community. So I had this, this style that I put on my toilet, focus on implementers, simple things simple. And the last line there was focus on the community. And we often say to each other within the FHIR core team that community now is our biggest asset compared to other standards. There might be technically better standards. We think we have the standard that's easiest to implement. But what we do have now is a living community, a very thriving community. You can see that if you go to chat.fire.org. First we started out on Skype with just the 5 of us, and then it became 10, 50, until we hit the hard limit there. Skype only allows 300 people on a single channel. So for some time you could only get on, it was a really exclusive club by then, you could only get on if someone else got off. And that was until we found a system called Zulip. So chat.fire.org is run by the system called Zulip, and we can have, and I think we do have by now, maybe 1,500 participants. And so we're starting to have a community that helps each other. No longer is it just the 3 of us who have to answer every single question coming in, luckily. We have our chat.fire.org where people discuss, and most of the time, lots of times, this still results in requests for changes. So people discuss, how do I do this? Well, we can't really do that. Oh, well, we need to formulate a request for change. Okay, here we go. Very visible, I think, the community at the FHIR Developer Days. Again, we organize this in Europe because 3 times a year there is a Connectathon in the US organized by HL7. But that's 2 days, or actually a day and a half, and the rest of the week is spent on standardization. Not everyone likes that. So we thought it would be nice to have 3 days of true hackathon combined with tutorial events. And that's what we do once a year at the FHIR Dev Days in Europe. Easy to reach for everyone in Europe. And this edition 2 weeks ago we had 260 people, which was double the size of last year. And we organized it around tables. So this is to continue a table here discussing devices, working with devices, and these people have been hacking together for 3 days. Well, you know the concept of a hackathon. It's so cool to see even competitors working together here to make things work. And the best example is this photo that was put on Twitter for a reason. This is me, just about to start a presentation here from Dennis Pettersson and Danielle Friend. Danielle is with Epic, and Dennis is with Cerner. And they were going to publish, to discuss the results of their Connectathon, of their common table. So they've been sitting working with app developers, building apps on their platforms and doing a presentation together. And I think that's, for me, that was a major event. It was just a little photo, but the fact that this is happening now, that these big vendors are actually cooperating here and show up in our European meetings to help other developers build apps on their platform is a wonderful thing. One of the most popular test servers in the cloud is the HAPI server, and James periodically publishes a summary of his logs. So where in the world, this is 2.15, I should have an update by now. Yes, we do see few implementations in Africa. We would like to change that. We are actively trying to get a Connectathon in Africa. We will offer our time to anyone who is able to organize that with a local authority. We would come over and help them because we would like to see more use over there. Maybe even fund travel expenses to come to a European meeting. I met with HL7 China last time. But this is the biggest one. This must be outsourcing. You know, I am contacted by people from India working for other companies. So this big thing here is is the outsourcing spot of the world for fire. There is a thriving community here in Argentina.
But in Russia, do they implement some server or just to use HL5?
I can't speak in general for Russia. There is an active group in St. Petersburg around the Health Samurai, and they have actually implemented one of the bigger open source implementations on top of, I was going to say Postgres, but I don't know if that's they've implemented that. And but they are sort of, I think, disconnected from a group in Moscow who did their first FHIR presentation just, I think, 2 months ago. So really, around Moscow, it's really early days for FHIR. While the Health Samurai in St. Petersburg have been working on FHIR already for 2 or 3 years. Mostly, I think, working on projects in the US. Well, yeah.
The current situation in the Finland about the FHIR implementation and FHIR integration, for example, in the Kanta services.
I think in the next session, after Eva's presentation, we will hear some more details about some of the FHIR users in Finland. So let's wait for that.
Well, I've already said that we've lost track of all the products that's being developed. Initially, it was even hard for us to get an entry in the Wikipedia because they said, "What's FHIR?" Every single team movie can get an entry in the Wikipedia, but FHIR could not because, well, we've never heard about it, so you stay under HL7. That's not a problem anymore. Let's say it like that. I want to spend a few words on things happening in the US, maybe. I have 10 more minutes, right? Yeah. Okay. So the FHIR-based specification said is pretty flexible. So what? I had some separate slides about this. I think there's an initiative called Smart on FHIR that says FHIR is nice, but if I want to use FHIR to immediately write apps against this, apps that run in the context of an EHR, we need to say more about authentication. FHIR doesn't say anything about authentication. We say authentication, that's the protocol. You can protect HTTP, you can do whatever you want. We don't want to be in the way, but we're not going to prescribe any specific authentication methods. Of course, if you want to develop a platform like Smart is, so you can write apps that run in Cerner and apps that run in Allscripts and apps that run in McKesson, you need to standardize on the way to authenticate. So Smart added onto FHIR decisions about which authentication to use. They also, and that's a little known fact, added content profiles describing exactly how to code blood pressure, how to encode all kinds of vital signs, which loin codes to use, very specific profiles. So this way you can build apps and be sure that they intercommunicate. At the same time, there is an initiative called HSPC that are looking at the service side of things. So how are FHIR servers used within the context of bigger processes, of bigger workflows? Can we define standard services around that? And then there's the Argonaut project. And the Argonaut project is an industry initiative, including the big names I've already mentioned. It said, well, standards development is nice, but we are a little bit afraid that these standard guys will once go off on their own thing, sitting, smoking cigars on tables, discussing standard endlessly. So we want to make sure that the industry is involved. So let us help you and write profiles for meaning-free regulation. It's a US-based specification for some of the data that hospitals are required to electronically offer to their patients and further. So the industry here got together and said, we'll start a vendor initiative to make sure this is going to work separately from, well, not completely separate, in cooperation with HL7, but still making sure. And this is actually, I think, in hindsight, for me at least, this is why all the major vendors started to show up at the Connectathon. They were slightly afraid that the US government, which they were probably doing, would say, we will develop new regulation, you shall use this standard or that standard. And then the vendor said, before that happens, maybe we should have an industry-led initiative and say, well, we'd like to use FHIR, and we'd like to have a big role in the profiles and how FHIR is used. Now we can still influence that. So these organizations came to our meetings and have written a set of US-specific profiles on how to implement FHIR in these meaningful use cases in the US. And this is of importance to us because this will get implemented in the big names. The Epics and the Cerners will probably implement FHIR the way it's described in the Argonaut project. So your question about if I'm an app writer, I'd look at what Argonaut is doing because that's going to be a big market.
Just to comment on that,
Yeah.
that's what I've been doing, and we've integrated with Cerner and Epic. And now our concern is if we want to play on our local turf with contact, they profile everything differently, then I can work with all the line codes for blood pressure or blood glucose.
Yeah.
But if there's in addition all these country profiles, then it's
Yes. So you are one of the vendor inputs where you'd say, well, if in Finland we do stuff totally differently, I have a problem, right? Maybe we can have multiple codes to solve things instead of having totally different profile. I think one of the reasons we are here, and that there's going to be a roundtable, is maybe to get a sense of that new help. This is chat.file.org, by the way. And so I've talked about this already. We have our request for change tracker. If you go to the specification, on the right bottom side of the spec there's a link, request a change. If you click on that, you get to our tracker and you can enter changes, change requests. And if you go to chat.file.org, you will end up in this this Skype-like platform. All the subjects, it's divided by subjects locally because there's an enormous amount of traffic there. And finally, I think in this part of the section at least, there's the FHIR Foundation. So in the future we'll see a situation, we think, where we'll have HL7 continue to work on developing the standard, but a growing number of people that are not so much interested in that process, but are interested in exchanging knowledge and organizing events. So we have founded the FHIR Foundation, which is going to be the home of the community. So chat.fire.org, fire.org is the website for the FHIR Foundation. Chat.fire.org is a very visible manifestation of that. This is where the community can exchange experiences, but we'll also have calendars of events. So if you are organizing a FHIR event, maybe in Finland, maybe in the Netherlands, you can advertise it there so everyone can keep track on where the events will be, the FHIR-related events will be. There will be this repository of extensions and profiles. We now have Simplifier, but we will put Simplifier on registry.fire.org, so you can go to registry.fire.org and find international extensions and profiles. We like to publish best practices and patterns, so if people ask me, what is the best way to implement IHE profile X? Is there any experience around that? Or if I'm trying to encode messages sent around in a social app, what is the best resource to do that? If I want to say that a patient has no latex allergies, what's the best way to do that in FHIR? This will end up in our best practices. And finally, a list of all the open source initiatives that we know of. So that's FHIR.org. I already did a summary on Smart on FHIR, so I'm not going to go fully into this. So I'll just say my final words. Finally, because we're getting to the next really interesting part, which is probably lunch first and then the roundtable, or first the roundtable. Ah, interesting. Okay. I think everyone knows this one, the Gardner hype cycle. And that's the idea that any product goes into some kind of cycle where, first of all, everyone is so happy about all you can achieve with this new technology, but then people start to use it and say, well, in the end it doesn't solve everything, which is of course the case with everything. And finally, you hope that you will end up at some plateau where people say, well, you know, it's not everything to everything, but at least it's usable. A lot of technologies, I think, end up somewhere here, and they never make it to this plateau. Well, some parts of version 3 never made it to the plateau. It's for sure that FHIR is somewhere around here, I think. I always like to warn about that. I've already, I think, said that all we wanted FHIR to be is to make it easy to implement health IT solutions. But implementing health IT solutions itself isn't easy, so FHIR cannot fix all. We just want to lower the amount of time you need to spend on technical issues and make sure you have more time to spend on actual functional and fun things that your app needs to provide. So I think if personally I look at FHIR, I think what we did achieve is that it is faster to learn, implement, and troubleshoot. That's the feedback we get from many people who start to work with FHIR. It is easier than version 3, it is easier to start. It does have a vibrant and open source community at these hackathons. We do get a lot of feedback, and that is, I can't stress enough how happy we are with all those feedback. If people would just say, yeah, we've used it and we looked at it, and nothing comes out of that, then you know you're not actually being used, right? The fact that someone complains an element is missing in one of our data definitions means that someone's actually trying to use it. So we are very, very eager to get this feedback. Certainly, if FHIR is being used outside of the context of the EHR context. Much of the testing so far has been done by providers of EHR systems, and I think we can use a little bit more feedback about the use outside of EHRs. And we have seen a lot of spontaneous adoption. So we're not using FHIR because it's a standard per se, but FHIR is easy enough to use, so we're going to use it anyway. So those goals have been achieved. Where we are not, what will happen now once we get past that curve there is I think that people will get more and more complex use cases and find that things are still missing, or maybe discover that interoperability on those levels isn't possible at all. But so we're definitely not there. We've proven that it's easy to get into FHIR, to start working with FHIR. Some real systems have been built with FHIR, but we're ready to get into that throw of disillusionment and to get feedback from people who say, well, now we're getting on to more complex use cases, and we do find, maybe something missing in the spec. We're bracing. We're ready for that. So there's always a but. We can make the technology a bit easier. One of the most difficult things with healthcare exchange has nothing to do with technology, but the fact that you try to make two systems exchange data that have different sets of peoples and different kinds of use cases behind them. We can't do anything about that. Interoperability is hard, but that's a human problem of common process and understanding. So I think that the standardization bit of FHIR will not be as big as the fact that we could make the technology a bit easier. Getting real plug-and-play interoperability out of the box is not going to be FHIR's. If we succeed in doing that, it's not only going to be FHIR's doing. It will mostly be, will enough people be using it as a community? Will they sit together to actually discuss how are we going to use FHIR? How are we going to use these profiles? For me, that's the biggest question. What we have out of the box is okay. But now, are we going to succeed in standardize across the board on actually making these apps work with multiple vendors? This is the time where we're going to test that. The coming years is going to be very interesting. So FHIR can fix the technology bit, but what we can't fix is whether people are now going to sit together and say, let's make profiles for these use cases between competitors, between regions, and see what happens. So we certainly no silver bullet for universal exchange. That has to happen because people sit together and make systems cooperate. So just want to make sure that we all understand that. And then I think this is my final slide. Any more questions?
I think this is a good time to thank Edward for the presentation so far. So thank you. And while we are switching the computer, and please Eva and Jonas, can you come in front? There can be more questions for Edward while we are making the preparation for next part of the roundtable. Yep. So please.
You need this one.
FHIR?
Yes, my slot.
This or you want
Okay, so we are moving forward in the program to the part where we are having a roundtable of some of the Finnish implementers and users of FHIR, and more discussion part. There are several other implementers in the audience and who are here as well. So let's move to that part. For this part of the program, we actually have three short introductions or a few words from some of the implementers. So the first one will be about the Finnish national PHR. It was supposed to be held by Mari Peltola-Nykyri, but she unfortunately got ill. So we are trying to replace her, at least partially, by two people. So Eva from Fujitsu and myself will tell some words about the Finnish national PHR work and how that's related to FHIR. Then we have Jonas Mäkinen from Duodakim, who is going to talk about the decision support things that have been done. Then Eva will also come back with some of the examples and demo type of things related to self-care and measurement apps. But that's just the beginning, and that sets the stage for wider discussion. There are several other ones in the present here who have also done some implementation work. And we are also hoping to get the discussion going with Ewa and Miriam, who are both part of this part of the program as well. So we can start with the Finnish national PHR. About then. And Eva, will you start? Yep.
So Mari was supposed to be here, but I'm overtaking this for her. I've been working with the Finnish national PHR project for quite a while, so I can answer most questions of it, and I have Juha here for support on the technicalities and everything else on that one. Finnish PHR project is the personal health record nationally for Finland, and the PHR stands for personal health record. This system is meant to operate in addition to the e-prescription and e-archive project we have in Finland, and add the data of patients themselves, at the well-being data, at the home measurements, at the self-measurements, and all that kind of data into the national system with everything else. Everyone, all the public and most of the private organizations in Finland are attached to the Kanta systems, the archive system, the e-prescription system, and this personal health record data will be available to them in addition to this. And it will be available to the persons themselves. it should enable the citizens to enter their own data, and it's in progress. We are planning to have the first phase of the national system ready by the end of the year 2017. There will be some profiles, some first trial profiles, trial systems, trials, and we'll refine and we'll develop it further. Why we chose FHIR? As it was not simple, it was more modern, it was better than V3. We actually do have a real-life V3 system in Finland that surprises the people from the Netherlands every year. And it was trend extensible, it was much more developer-oriented than the V3 standard. We wanted to have all sorts of mobile systems, all sorts of modern systems with it. It has JSON support, it has REST services, it has simpler interfaces. And it seemed more accessible, it's much more extensible, it has methods within it to describe it. And as it will be part of this kind of ecosystem here in Finland, I think most Finnish people do realize what's in here. Here's the patient data repository that has all sorts of official clinical data. It's the Arkisto in Finnish. Then there's the e-prescription. Then there is the future cancer services. That will be social services. And then we have the personal health record. Then there is the Omakanta system and all sorts of apps that can have access to the personal health record. And through the Kanta messaging layer, there will be links here. There's a small line here between the systems so that the data will be moving across the systems.
One question about here, because now Kanta supports the CDA. If you need to just communicate, support FHIR, you need to have like just adapter. We will adapt like JSON model to the CDI messages to send to the Kanta. Or will Kanta be moved later to support FHIR standards?
I personally don't know about such plans quite. I think Kanta will evolve in the future. But Kanta as a clinical data storage for the big systems like health record systems and so will still be based on the CDA documents. But the data from FHIR will be available to those systems to be included.
Yeah, the question was about the relationship of Kanta, of CDA and FHIR in Kanta services. And the current first versions of the national PHR will be mainly based on the FHIR interfaces. And if and when there will be the access to the clinical documentation, the official healthcare documentation, there are the CDA interfaces you can already use. So we are trying to avoid overlap at the first phase of the development to get the personal health record data through FHIR interfaces, which is owned by the persons or the patients themselves. But those documents which are, have a healthcare custodian, there are still CDA documents.
Yeah, well, we'll have to see in the long run,
yeah.
But not the first phase.
Mm.
Any more? I think they should be familiar to most people in Finland. The ecosystem, and the EVA probably has spoken about the possibilities how to profile, how to create resources in FHIR. So there will be open process to ask changes in the Finnish national profiles. The process for making the profiles, process of defining the profiles run through HL7, and you can tell about the details about the profile process.
Yeah, actually the process has been discussed several times in the personal health special interest group in HL7 Finland, and the board of HL7 Finland and the members of HL7 Finland have been quite active and willing to participate in the development of the national profiles and the implementation guides. And so the draft of the process has been developed that actually has pretty active role of the special interest group as a collector of different kinds of interested parties. and many of the definitions and the specifications for the first profiles and implementation guides have already been discussed. But when we go to more detailed level of different kinds of resources, there are quite a few of them. So it may be that when the development work becomes even more active, it needs to happen more often, and we are looking at ways to utilize different kinds of electronic, commenting ways in addition to meetings every few months. For example, in the next year's action plan for the association. But that's been a collaboration between the HL7 Finland and the THL and Kela. And I think the feedback so far has been quite positive from the members of the special interest group as well.
Yeah, the important part here is that anyone can offer a new profile or extension. It can be like a draft, or it can be quite finalized profile. It'll then go to the process, which has some sorts of verifications, whether it makes sense, whether it's clinically sensible, and so on. Depending on the maturity of the profile, it'll be faster or it'll need more rounds of comments. And then it talks about using Jira or GitHub for the commenting and for submitting the new profiles. And this is just a quick show. We're trying to actually map what we're doing to make sensible that these sorts of stuff will be observations, these sorts of stuff that we actually have in Finland will be questionnaires, there'll be data model. And currently, there is the sandbox. Currently, we are using the STU2. We are hoping and looking forward to STU3 quite fast, please. And the sandbox is using the HAPI FHIR. It's part of the sandbox. We'll be probably using parts of HAPI as part of the FHIR backend. And then we are using the simplifier to publish the profiles. The profiles we have specified are available in the simplifier under the project HL7 Finland. Please look them, please comment.
Okay, so that was the first part. Any immediate questions for Eva or the conduct things? We can also save them for the discussion.
Yep.
Can you explain a little bit more what you said about TSU3 and validation?
Yes.
On the previous slide, you said, yeah. It said that DSU3 was necessary for validation.
That's related to that the sandbox is using the HAPI implementation for the STU2, and many of the profiles in Finland have slices in them. And James has written the support for that in the STU3 edition. But as our profiles are the STU2, they go through the STU validation. It doesn't have the support for slicing, it's just the technical stuff.
Oh, okay. Yeah, so we will soon have slice validation in DSU2 on the simplifier, so you could use that too. Yeah.
So just basic technical stuff about that.
All right.
Current sandbox is available in public for everyone to use.
Okay, let's take the next presentation then. And Jonas is going to tell us about a little bit about the evidence-based medicine decision support.
Yeah, right. Thank you.
You can come here to change this.
Okay, thanks. First, I think I should mention, some of you probably don't know what our product is. EPMED's evidence-based medical electronic decision support. It's an automatic decision support system that's already implemented to several healthcare systems. 3 of the largest in Finland, including FHIR, Pegasus, and so on. And so this is not a prototype. This is a real system. What we wanted to do with FHIR, originally years ago, when we were discussing what kind of interface to build for the decision support. HL7 version 2 or 3 were discussed, and CDA and so on, but they are pretty complex standards, and we were worried that we are not going to get any customers if we choose any of those, because just making the interaction happen between our system and the healthcare record system is so complex. So we have been using our own EPMEDS XML schema, which is a pretty simplistic XML schema for drugs and diagnosis and lab results and physical measurements and so on. But now I think the FHIR is a rather interesting opportunity for us, because it has gained so much popularity recently, and we want to build EPMEDS FHIR plugin, which can communicate with the FHIR server, and then it translates the FHIR resources to our own XML schema. For the time being, we only use plugin. Of course, we could do it directly with our engine, but now it's better to have a kind of translator in between. And also one nice thing is that now with this FHIR, we can also, that's the wrong slide anyway, we can ask for more patient data if we get too few. Like if we notice that, okay, for this patient we will need also these lab results. Let's check if it's available somewhere else. And with the FHIR, we hope we can do this in future. So we have done a few implementations. These are more of a prototype implementations at the moment to our existing tools, and we have been using Smart on FHIR. Well, we have two smart apps in the Cerner system available at the moment, and then we have been using a thing called CDS hooks, clinical decision support hooks, which has gained some popularity recently. Well, we hope it will be it will be popular also in future, and maybe if we code it, then it will be, like you mentioned. Okay, so here's an example. This is the Cerner app. There's a list of smart apps there, and we have a couple of apps there. In reality, some things are still complex, and that's of course the most complex thing always is the coding systems, because every country has their own, and even every system seems to have their own. And here's another case where this is consuming patient data from that patient has recorded, or some devices like a blood pressure monitor and then this Withings weight scale that you automatically get the data, and now we give some feedback to the. Well, actually, this feedback is for the doctor that treats the patient, but it's based on the data recorded by the patient. Okay. Our experiences. Yeah, I think it was fun to get started with. This is useful. It's a rather practical standard. There's a lot of documentation, and if there's no documentation, you can always Google it. And as I mentioned, it's popular. There's all the time new ideas and new things happening, and I think this is a good opportunity for new business, since so many vendors are now providing FHIR service. And even the major players like Cerner or Epic, along with the smaller ones. And then, of course, this challenge is the first one is not this. This is always the case with everything. First, it seems okay. This is so easy. We can do this in a week or so, and then you realize that you have been spending a month and it's still not done. There's so much things to define. Like in the spring in this Omakanta PHR, just defining how to how this blood pressure resource is going to be implemented in the FHIR server. That's already a big thing. You have to spend time on that, and that's not the only one. There's so much things that need to be worked on, and the FHIR servers are different. With the same program code, you cannot use Omakanta, this our personal record PHR, and the Cerner server. They use the FHIR differently, and there's always some unexpected events. And this has been already discussed, but I want to mention it again. This is something that is on continuous move. Everything changes all the time, and suddenly we realize that in spring we made something, and now we made something new. So we had to change some things already from the spring, because the definition, the FHIR definition had changed already, and it's rather hard to keep up with that speed. Of course, I think many things will settle now, like Ivo mentioned this, that there's the maturity levels, and many things will get more stable soon. Yes. And of course, this from clinical decision support point of view, everything is really premature. Everything is just initial. Some things are going totally different way than that would be suitable for our solution. We don't know if CDS hooks is going to exist in 1 year or not. We'll see. Have you got any questions or comments at the moment?
Yeah. Okay. Thank you, Jonas. So, quick questions for Jonas.
Are you using SU3 or 2? Because you said it changed all the time, so I'm assuming you're using the newest version?
2, but it was like because of course because now we did something for this server smart apps, and they were behind the change, so and of course now.
And CDS hooks still changes.
Yeah.
So the comment was that CDS hooks is still changing a lot, and they were using DSTU2, right? Yeah. Okay.
So I'm here with as well with the Fujitsu actual demo that we built on the personal record and with real life equipment. This is just medical continua compatible blood pressure meter that sends the blood pressure measurement over wirelessly, and this is something that could be given to patients at home to support. I will have the hardware here available if anyone actually wants to see it. But for this demo is blood pressure monitoring and basically using the resource as it was defined with the work group at the blood pressure and putting the data in the personal health repository. It sends the observation via internet wirelessly. So behind the scenes, the demo was done in cooperation with Medicine, that's another company in Finland, using the Medicine suite. So this is at the home, the patient measures his blood pressure, the meter sends it over Bluetooth to the modem that has 3G roaming SIM. So the modem itself can send it over the mobile network, goes into device cloud. The Medicine, I'm sorry, I'm here instead of someone else for this one. And the modem sends it to the Medicine suite that's resident in Fujitsu cloud. The Medicine suite is for patient's own patient measurements, patient data for that's not part of the PHR, but it's different suite for data. And then the Medicine suite itself is integrated with the Finnish PHR system such that the suite sends the measurement as FHIR resource to the national PHR repository. And the device is mapped to the ID in the PHR repository. So the device, through the Medicine suite, this device here, that the technical part of it is handled in the suite, is mapped to actual patient directly into the cloud and into the PHR system. When the PHR system here, through that one, it's also available to the healthcare doctor and professional and can have the data visualized in her dashboard. She can see the measurements of the patient there. Goes through the cloud and everything will be happy. So, as part of the demo, we saw the benefits of integrating different systems. We saw the benefits of integrating the Medicine suite, as it will free patients of seeing the doctors for measurement. It will make the available information immediately available to the doctors. It will be made immediately available to clinical decision support systems. So there will be integration between operators. The data is available in the storage, not on some pen and paper system that's like classically used currently in many cases. And it makes it simple for patient to collect the data. The point is, patient only needs to press one button on this device. They just need to press this one and it goes to the existing Medicine server that's available to patient already. And I'm sorry, header is in Finnish. This is part of the desktop demo we have in Finland. So this shows that all the imaging studies in Altian, that there is the medication and risks, and this is the like a graph for the measurements that the paper has done. This is all the time. Here is the demo. So there were many measurements done there. And the actual measurements here, you can see the actual data. There's quite a bit of variance because we have many demo users. There's lots of different people, so this demo patient is getting quite. You can zoom in and see that. And this is the desktop for professionals, so they'll have the personal health data available there. And also, actual measurements, these are fetched from the as FHIR resources from the Finnish national database. And well, we tested it a few days ago, so they're quite a demo. It's just quite simple. Implementation didn't take too long, and it worked with existing cloud systems we had, and we were able to integrate those. So this is about it. Anyone has any questions?
Do you have any interpretation or consolidation of statistics with regards to the blood pressure measurement?
No, this is just available for viewing the data, so the interpretation system would have to be separate and work on the same data.
So do you have something like that in development? Or
I'm actually working on the national PHR, so I don't know about the Fujitsu plans elsewhere, so I can answer more difficult questions for the national PHR.
Okay.
Sorry.
For the questions in the audience, let's wait for the mic. So.
May I reply to that?
Yeah, the question was, previous question was that if Fujitsu had any plans for any analysis software.
So hello everyone. Pontus Ilman from Medicine. You asked about interpretation. Our medicine suite supports, for instance, limits and other things like this that you can do. Like Eva said, the data can be shared with CDS modules, which are additional interpretations. So it's part of our.
Yeah, thank you. and the demo was in cooperation between different organizations.
Other questions? Or comments? Yeah, actually, here you can see the participants of the demo, and then there are several here also. So this was part of the Terveydenhuollon Artekopäivät trade show in May. Perhaps some of the participants would like to have some comments. Topi, do you have something you'd like to share? For example, there are others involved.
Thanks. So Topi from Lääketietokeskus. We made a really simple demo based on how to input your medication to Kanta PHR, and actually also a link to what Jonas just presented using a different interface so that you could do a medication review for those medicines. It was a really easy exercise, and the developer who made the demo was really happy so that he could just start from the scratch and do it in a couple of weeks.
Mm. Okay. Yeah. How many others? Yeah, Mikael.
Yeah, Mikael from Sensbrand. We also took part in the demo. We built Smart on FHIR integrations to Epic and Cerner and FinLab systems. And the best thing about that was that both Epic and Cerner had those FHIR sandboxes freely available on web, so we could start working immediately and then work on the business relationships and so on once we had something to show. That really helped us get it further.
Yeah, okay. Someone else wants to comment on the... How many have been trying different kinds of implementations already? Not very many of the audience in person. Yeah, okay. A question to Miriam and Eva then. How does this sound? Is this very typical way the FHIR has been used, or do you recognize some special things? If you listen to the users that were talking about their experience here.
Well, actually, this is the first demo I see where a real national PHR with a FHIR interface is being demoed, because many of the demos I see are connections between an app and a backing server that is, for example, made by the same producer of software, or apps that work on Cerner and Epic. But it's interesting to see your whole picture going all the way through your device cloud. You know, it's a big circle, then to the cloud, and then finally back to the doctor. I had not seen that before, so especially interesting because we try to achieve the same thing in the Netherlands, but we are not there yet. So that's as far as I've seen it. Yeah.
Okay.
So good job.
Yeah.
Okay, thanks. And I think it has been very instrumental that lots of people have come together. The demo was very encouraging. We have had some sort of demos in HL7 Finland before related to IG, for example, but this was in a few months. There were so many companies who got involved and found partners inside the big group of different kinds of organizations. So it was very encouraging. And it had also had a very good community going, so we should try to maintain that. Okay. So we are getting ready for the final words for this event. So a few words about the next steps. Well, I'm not sure how many of you have been looking at the HL7 Finland action plan for next year, but there are quite a few things that are related to FHIR. Well, we are in the moment in the board of HL7 Finland. We are preparing a call for proposals for projects for next year. So we are hoping that you are active and you make the proposals when we set the call out. So at the moment, most of the FHIR activity in HL7 Finland happens in personal health special interest group, but it doesn't have to be like that necessarily. If we find active people who are interested in use of FHIR in other contexts than personal health, that's also possible. We have an active technical committee and we have IG, and IG is also looking at many FHIR related things. So please make suggestions. The national PHR work mainly takes place in the personal health special interest group in HL7 Finland, but that's not the only possibility. So, of course, that's one of the things that the FHIR is highly visible, but that's not the only one. There are several other things related to personal health or asiointi or electronic services for consumers that are also interested, including appointment booking and things like that, which are also, there is some considerable interest in those as well. And it could be used for many other profiles and many other implementation guides as well. So some of these are related to new patient and client information system interfaces. There are high profile projects like Apotti, Una, and projects like that, who are very much looking at different kinds of interfacing things as well. We do have training courses planned. We already, this is the second one of training courses this year for HL7 Finland, and those are, we aim to have those next year as well. But we are looking forward to your feedback. How should we focus the courses? Should there be implementation exercises, lots of hands-on work or not, and what kind of level we need, because that's how we are trying to focus things. And of course, there has been discussions about repeat of demos. Again, maybe not next year, but if we get a good group together, it could happen still. So there are lots of plans, but all this depends on the participants, and all this depends on you, because the association just works through its members, and the projects also are based on the proposals that you are giving. So please be active. So the concrete things are happening through the groups, happening through the mailing lists. If you're not on the mailing list of the personal health, the special interest group, drop line to me or some of the group leaders, co-chairs. So you will be added. They are open lists. They are not for members only. So some of these lists can even be attended, even though if you're not a member. But I guess for today's program we are running out of time, and it's time to thank you all for attending, and also those who were online. And the presentations, the materials will be available through the web. All the registered participants will get the links to those. And those of you who are participating in the training session, it starts at 1:30 here. And everyone who is here on site, you're welcome to go to the lunch, which is on the opposite side of the corridor. So thank you very much for this day, and I hope it was useful for you and you can bring home some good lessons. Thank you.